is, Rob, and we are back with Ultimate Spider-Man, and Peter Parker is getting a new suit in the Ultimate Universe, and it's amazing. That's only the tip of the iceberg, right? Like, all kinds of crazy stuff happens here. So what this does is this initially picks up with Peter Parker and Harry Osborn meeting up with Otto.
You're unmuted.
Moments where there's a really cool callback to the original Ultimate Universe in Marvel Comics, Earth 1610. Because remember, this is the new Ultimate Universe, Earth 6160. And the reason why I say it's a cool callback is because in the original Ultimate Universe, Otto Octavius was a lab assistant for Norman Osborn. And here, it's much the same way, that Otto was hired on by Norman before his death, before Harry took over the company. And so Harry kind of brought him on as well. But the reason why they're all basically meeting here is because they've been trying to figure out the nature of their suits. That's one of the things to keep in mind. Harry Osborn basically has his suit by way of Stark Tech after the death of Howard Stark and Tony Stark taking off into the future to kind of deal with everything. As always, if you need to get caught up, there's a playlist at the end of all this. The important thing to understand is that they're using Stark technology. With Peter himself, his suit was presented to him by Tony Stark personally, but they still don't know a lot about how their suits work. And that's one of the things that Otto says. He says, your suits are both Stark Tech, but they were built using two completely different types of engineering. Call it Stark 1.0 and Stark 2.0. And he says, Harry, your suit is basically a dedicated piece of very sophisticated hardware, top of the line, flawlessly constructed. If pressed, I'd actually call it the perfect war machine. I mean, it is more than that, sure. Navigation, propulsion, and onboard AI. And that's something that we'll get back to here in a second. But as a piece of tech, I can get inside it, customize it, do whatever we want. We own it now, top to bottom, front to back. But this Picotech suit of yours, Peter, it's beyond that. Highly adaptable, transformative, and it's going to take a bit more time. Now, one of the things that you guys are going to realize here is that Jonathan Hickman is doing something really cool with Picotech, because to kind of bring this in, right? Picotech is not like nanotechnology, and it's not like a traditional Iron Man suit. Picotech is basically like restructuring and allowing the atoms of the suit itself to form whole new molecules and different things like that, almost as if the suit were alive. And so what you get here is Spider-Man just kind of like, look, are we sure about this? Because number one, Otto just kind of seems like a really weird guy. And two, we don't know where his loyalties lie. We know it lies to you supposedly, but what if they got to him right now? Of course, I'm kind of offering that little bit of an exposition myself, but when Peter, or at least when I imagine Peter saying they, of course, we're talking about the Illuminati, who we'll talk about here in a second, because they do come back and we do get something really cool that goes on here. But what Otto tells them is, he says both suits run on the same network. They don't have to, they can operate independently, but while they do, they're subject to network commands, which is how Harry shut your suit down the first time the two of you met. Now, that was a really cool moment.
Give me 1 sec, okay? Just gonna, when I have the chance, I'm gonna try and change this. Select reactions to add more impact to your gestures, okay? Select. Well, I don't have background and effects. Is that what it is? Or a video filter? Where do I find reactions? Does anybody know with the Mac interface? In Zoom. Well, let's try background and effects. No, so that's not what I'm looking for.
Are you looking for the MacBook reaction things or the ones on Zoom?
Yeah, well, I'm getting a message every time I start Zoom. I'm getting a message saying turn on reactions because Zoom has turned off reactions. That's why we're not getting those balloons. But I'm getting a message now saying Zoom has turned it off. So you can turn it on by clicking on the video button.
Yeah, just go to like the top bar on your Mac, and then there's like a green button with a camera on it, like a FaceTime.
Oh, that one.
Yeah. And then you press it, and then you press reactions.
Okay, I can see it now. This is so crazy. There is another camera button on the screen, and I just got locked into it. There's you see the camera too above the video at the very bottom of the screen. That's for your camera or something like that. Well, I don't know. There's two camera buttons. So I think the wording of that message was actually wrong. From a user interface perspective, someone who's trained in linguistics and prosody and things like that, they would basically have pointed it out, saying, hey, you know what, in Zoom, well, I'm talking about, in Zoom, you know what, you actually do have two cameras here, so you got to be very specific, or because, like 1.01% of the users will be confused, okay, and they may waste like a half a millisecond or whatever it is. It's sometimes it seems, and I've made this point before, how come you two guys are, taking up more of the screen than the others? Hang on one sec, okay? View gallery. Yeah, okay, now you're all on the screen. Okay, previously it was kind of, yeah, what was I saying before? I don't know. It doesn't matter so much. Maybe it'll come back. Okay, so anyway, welcome to class. I'm like super excited. This is midterm week, and then we will start talking about objects next week. Okay, so today I just wanted to be a review of everything we've done so far. In fact, what we'll do is to fill the time until someone says, hey, you know what, it's midterm in 2 days. I want to better understand passing parameters by value versus copy, right? Some examples. And then you get like 10 minutes, and then I'll just walk you through a live code, like in online GDB. I'll walk you through an example that you can both share on the Reddit, as well as get a real feel for what it is, and we'll do some experiments. Like, for example, we'll write a main and we'll write a function and we'll pass it by value versus reference and see if it's what changes, what doesn't change. We'll run some experiments like that, okay? So that's the kind of thing. Or you could even say, hey, this is, CS2A. I keep forgetting it is CS2A because you guys are, advancing quite rapidly. You could even say, hey, I actually have a problem with, different looping structures, because we just, skim through it really, right? So you can say, hey, can we do like 10 minutes? Walk me through like the same thing said in 5 different languages. No, that, not like that, but it's the exact same logic using a do while loop, or a while loop, or a for loop, or a for each loop. There's so many different ways of doing it, right? We won't go into a recursive, because the recursion is, it's not really a loop. So we want to talk about things that can loop infinitely, not result in a crash. Because if you think about it, a recursion, people talk about recursive loops and things like that, but there's really no such thing, because a recursion is actually progressing towards something, because at each step it's probably eating up something, right? Or at the very least, stack space. It's got to push its return address and things like that. We didn't cover that. Okay, so that's another thing you could ask me for. Can we talk about that for 10 minutes? Okay, and you can keep tabs on time and say, hey, prof, like 2 more minutes, and then I got to give the the mic to some other student to ask their question. So you can actually keep tab of this, 10 minutes per person who asks a question, and anything that we've covered so far, or things that I've promised I'll cover, but I never had a chance because I've been waffling too much. So you can bring that up too and say, hey, why don't we talk about the stack and the role of the return address and stuff like that during recursive call. Strictly speaking, I skipped that because I realized it's not part of the CS2A syllabus. I don't actually examine you in the midterm or the final saying, well, you know what, this function is being passed 3 parameters, which are double, and it has to store the return address. So how many bytes are pushed on stack when this function is called? Okay, so that would be a very interesting question, but it's also an unnecessary question, because once you know how it works, you don't really care about the details. All you need to know is, well, you know what, this function needs to have a way to access things that are passed to it. Okay, so meaning that the caller has to say, do something, but do something with these things. So it has to pass these things to the function, right? Either so it can either make them global or put it somewhere and say, go and look there. There's easier ways, and that is where the stack comes in. So what happens is the caller will basically, before calling a function, it's going to take all the things, the parameters the function is going to need, put them on stack in a very specific order. Okay, it says, oh, the first integer, then a string, then a double. Okay, it has to get the order right, because the caller has this contract with the callee, or I don't know which direction it works, saying push it in exactly the same order in the stack. because when I take things out, I'm going to take it out in this order. Then otherwise you'll end up, assigning N1 to N2 and vice versa, or, integer to something else, and you'll get all kinds of errors, right? So you got to match up correctly. So the stack comes in useful, but the most important thing that has to go on the stack is also, after all the parameters, it also has to say, when you're done with everything, here's where you come back in machine code. This is the address, right? So that is called the return address. So that is a difference between just jump to a statement and then run from there. Don't care about coming back. Okay, that's a good one. It's really fast, also confusing. We hardly ever use it these days. But a function is most structured, because it says, I'm going to throw you somewhere, do something, but you're not really done. Okay, you're still bound to the empirical bounds of this computing machine. Okay, so you're not free, because after you're done, you got to come back to me. And that function may, send the CPU on a different function altogether. But every time, it has to come back and fulfill the obligations. It has to walk its way back and get rid of all of the return addresses. So those are where the return address thing comes into play. It's actually very interesting, right? And I wish it was part of CS2A. But the reason I don't talk about it is because sometimes I get carried away, because it's very beautiful down there. Okay, because a lot of it is like going to watch an elaborate and very beautifully performed dance, where there are so many fine moves that most people won't even notice. But if you've seen the dance like 50 times or 100 times, then you're not looking for the large scale movements, which also have to follow time, but you're also looking for the micro movements within the large scale movements, right? And the dancer, because they've practiced it like thousands of times, they know exactly where to emphasize each one of these things. That's why these, pieces, art in general, gets better and better the more time you look at it, because the more coarse or the bigger detail basically just fades in, and then you can concentrate on the micro detail. It's the same with programs too, I think, in many ways. That's why, programming is an art. That is why we should never feel threatened by AI or some alien intelligence that's like super duper powerful, right? A super intelligence, anything that comes and takes over. You're interested in this not for anything or someone else. You're doing it because of artistic desire to see structure and marvel at it. That's the only reason. Why do people paint? Right? Even if nobody's going to look at it, make music, paint, all of these things. And programming is one of those. Math, right? Whatever you're interested in. And I always recommend this, other than music and things like that, for which you don't need resources. Yeah. Maybe for music, some kinds of music, you actually need external resources. But, for the sense of music, or just even, training yourself to sing and all, no external resources, right? So computer science, math, a lot of this can just be worked out in your mind and with very minimal resources. But there are other things too, where you could potentially do these things, but you'll be dependent and beholden to the real world in many ways, right? If you go to a lab science and you got to do this experiment, or wait until the next super duper eclipse to happen before you can verify this astronomical theory, right? All of these things, there are all these expectations and time frames. You got to be more patient. It's also more expensive, right? You got to hire equipment and stuff like that. More effort, really. You got to move more atoms, whether it's your own bodily atoms or atoms out there, but you got to move, right? So very few things can give you that sense of fulfillment that don't require you to move anything in your head, anything in your body except maybe electrons in your head. Right, so you can just sit and so computer science is one of these. So we don't have to feel threatened by I look at Google, and sometimes I get these recommendations, and people are panicking and is computer science education going to be obsolete, or people is it worth learning to program and shit like that? Okay, but why would a real programmer ever feel threatened? It's just because someone else is going to do a better job at that particular algorithm doesn't mean that you're not going to program, right? You're going to learn it just because it's fun to do. Yeah, like in art, just because someone else made these great art pieces, you're not going to not paint, right? You'll still try your hand at it, these things, because it's inherently fulfilling. That is actually very good, I think, for the future, because a whole lot of people who are just there for the certificate anymore, right? They will cease to learn computer science. The only people who will learn computer science are the ones who actually love it, right? Any art for that matter. So because there's no point in learning this for the certificate or getting a job or things like that anymore. You will actually learn it because, well, you know what, this is amazing. It's like a fractal. No matter where I go, there's more detail to discover. And every time I discover something, it is, it feels, those are the things that you will be looking forward to, I think. So yeah, I am totally for. Okay, if there is AI, that is fine, right? You can use after you do your own code, you can also use Chat GPT or something else to create the other code for the same quest. Okay, maybe you can give it the PDF. I haven't tried, and say, well, write the solution. I'm pretty sure people can do that today. Yeah, because the PDF can be converted to text, and it can read all the instructions, and it'll churn out the program. Pretty sure. Okay, any decent AI today will be able to solve these quests. But you should the same rule as past Reddit. Okay, because someone in CS2C asked a question: can we look at the past subreddits? Or someone said, I looked at the past subreddits. That's how I was able to solve the quest. And someone else said, no, you should not look, because same rule for CS2A also. Don't look at the past subreddit. You can look at your current classmates posting. Okay, but don't look at past years, past quarters subreddits until after dogging a quest. Okay, so even if you have the last 2 trophies, it's very tempting to say, well, you know what, I've popped it, I just want to get dog and see where the hell I'm missing those 2 trophies. That is itself huge. Finding where you missed the trophy is actually fantastic. You should don't look at the cheat sheets and say, well, you know what, this is the trophy list, and then you're missing one line here. Okay, that is not a fun way to do it. Okay, so you just look at the spec again, and then look at the trophies and say, well, did you cover all the points in the spec? Okay, and sometimes it's actually fun because it may be in a little bubble. Okay, I think it's inconspicuous, but you'll discover these things. That's why it's more fun to just do it yourself. So don't look at the past Reddit posts. You guys are not doing it, I think, but maybe in 2B and 2C people are. I just have to remind them. Yeah. Okay, so anyway, enough of a spiel. My God, it's like 6. For some reason, after it rebooted, it's about 15 minutes. Yeah, 15 minutes. Okay, all right. So I guess, the crowd is not going to get any bigger now. I think it's just us. So what we'll do is, who was the last person to code last class? Was it Mir? Hey, Mir. Mir, are you there? This is Jacket. Okay, we can't even see you. All right, now we can see you. Okay. Did you code last class? You did, right? So did you share that last URL? Online.
Where was I on your list? And the response of Tony,
hello? Can you hear me?
you weren't on the list at all. But the fact that you're hanging out with
Hey, Amir, are you watching YouTube?
Hello?
Yeah, were you watching YouTube or something? There was news program playing on the speaker.
No, I'm using my speaker, sir. I'm alone on the campus.
Oh, are you? Oh, you're on campus.
Yeah.
Oh, yeah, of course. I recognize the ceiling and all. Is this STEM lab?
No, this is the WLC.
Oh, the WLC. Okay, all right. Okay, cool. Anyway, if you share that URL that you had from last class, yeah.
I actually made edits to the code, sir.
Yeah, I know. You also made a post of the thing, right?
Yeah.
Can you share the original one before you made the edits?
I don't think I have that. I remember, I think when we were editing it, I lost the code and someone else pasted it.
Oh, I don't want to pick up your version or Sumit. Sumit, you also, well, anagram is the one we're talking about, right? Not the positioning the column. Anagram was the last thing we did. No, mean, was it? No, anagram. We did the column positioning thing, and then the meanie, and then we did this anagram. Not anagram, unjumble. Yeah, okay. Yeah, I don't want to use either your. You should try these things, okay? It's very, like Sunit observed, it's very catchy. Because if you play like 4 or 5 times, that's like 10 or 20 minutes down the tube immediately, right? Because it basically sucks you in. You always think that you can do better than yourself. that is I think it is a really great business idea, isn't it? Because if you can build on top of that, you can basically get into the minds of every single person out there, because everybody feels that you want to be not better than someone else. You always want to be better than yourself. And this game basically brings that out in you. Because I got it in 5 point some seconds, right? Each word on average. But I think I can do it in like 2 seconds. I just need to practice a bit more, because off the 5 seconds, a lot of it was spent just getting my eyeballs through the text and locating the word so once I get used to that flow, I can focus in this, I'll know exactly where to look. So all of those things will help, just like in a real sport, I think, except here, you don't have to do it so many times. I think like even 10 or 15 times. But next time I'm bored, I'm definitely planning to play one of our classes games. Okay, maybe I'll make or someone at sometime this quarter can make a link to a list of all of the interesting
I mean, I
links, games that we've developed, games and other things, right? For actually next week, no class on Thursday. Okay, Thursday is when you're going to be taking your midterm. Yeah, so no class on Thursday, and next week we'll start working on objects. And I think what I'd like to do is with objects, start with a project that will take about 3 classes to get really awesome, but in the process will expose you to all of the core ideas of object-oriented programming, and so on. So in fact, what I was thinking was I tried to think of a new idea, but I don't know, maybe I'll come up with a new idea, but otherwise this is what I'm planning to do. Can someone share the screen really quickly and go to a browser? Yeah, and then anyone? So this is what we did like 3 quarters ago. Nobody's picking up the screen? Okay, Enzo, thank you. All right, yeah, just go to Reddit, Reddit/r/CS2A, our class subreddit. Yeah, CS2A. Yeah, hit enter. And then in the search bar, say, one sec, okay? In the search bar, what we want is ANSI, ANSI space workout. Okay, one word, I think. ANSI workout. Okay. Yeah. Okay. All right, that one, the first one, 1 year ago. So actually, this must have been last spring. Okay. Yeah, click the speaker and then play it. Yeah. So this is what we did, but I think we can do much better than this. Okay, so we'll try and do this. November 9th. So it was last winter, huh? Okay.
Can you guys hear this?
Yeah, play it. I want to. So we can do this, right? We can do this. This was just done in one class, in fact. Okay. Right. No, yeah, I see. It's that one. No sound? How come there's no sound? Maybe you got to share. Never mind. When we do this actual thing in class, we'll try and see if we can get sound. Yeah. Run it. You got to run it. Oh, no, they're running it.
Yeah,
we
it's a
have
video.
control. Yeah, it's really cool, right? But we can do more sophisticated, cooler pictures. Okay, all these things, and I'm thinking what we'll do is generate a screen class. Okay, using the techniques that we know already and sleep and stuff like that. We'll generate a screen class to which you can show frames like in a movie, so 16 frames per second or whatever it is, and it's gonna, and then that's how it was done, and it's less than 100 lines, isn't it? That's all. See, 109. That's all. We did it in one class. And I was very impressed with, the music fitting in very nicely to this animation and all. Okay, so we can do something similar, except that we can do a different movie. And then for extra credit, the guys that, fork the class thread on and do their own thing and then share it, that's really cool. Okay, so, at the end of the quarter, you can actually make a whole list of that so that people can just click on it and see it, look at all the fun we've had. All right, okay, thank you. Yeah, actually, if you do the credits, not now, right? If you do the credits, you'll actually see the names of all of the students. So, like we do in this class, because all of you, if we generate a movie in the week 7 or 8, we'll make something like that, okay? And it'll be fun. Yeah, and we'll think of some good ideas in the meanwhile. If not that, but that's a backup plan. Yesterday, I was thinking about it. Okay, so what do we do for objects? And this sounded like I can do better than that right now. All right, so that's what we'll do next week. No class on Thursday. And today, someone should pick up the screen and go to this code that hopefully Mir had shared last week. Okay, so it must at least be in your history, that online GDB / that whatever that URL is, must be in your history or something like that. If it wasn't, it was shared in the chat of last week. Someone should have it. If you do, yeah, let's go to that. Otherwise, don't worry, okay?
Are we gonna get a practice test
'Cause we're
Yeah,
looking at-
so when is your test? Yeah, it should already be open, I think. It's Monday, Tuesday, and Wednesday. The practice test will be open Monday, Tuesday, Wednesday. But I
Okay.
think there's only like four questions maybe, and 4 or 5 questions, and it's just they're not representative of the actual questions in the midterm, but they are representative of the format. So it'll just get you warmed up for, all right, I have to do these things, and I don't have time to look in or copy and paste into an IDE, run it, and take the output and put it, click check A, B, C, D, is not a good strategy. Not just for the midterm, even out there professionally. You want to get more into the mindset of not having to actually run code to know what it's going to do. And the thing is, what happens with newbies I've seen is that hey, this is really strange. Maybe one of you who's also doing some computational psychology experiments should do an empirical test to see if it's true. So what happens is that newbies try and for everything in the code that they're going to use, they try and I think visualize all the nitty-gritty details of everywhere that the code could go and what could go wrong and all these things. So they're spending a great deal of intellectual energy just doing that. But the more experienced guys will see that, okay, and they don't look at everything, and they just take a lot of things for granted. I say, all right, I can trust this library to do these things in nlog and whatever it is. Okay, I'm just going to look at the API. This is what I need to give it. This is what it's going to give back to me, right? So they have a really solid understanding of what that give and take is. They don't bother so much about not that they don't know. They know what's going on. But they're not going to be bothered about the details of it. Whereas, young newbie programmers, you have to, right? Really, you have to, because you can't really say, I'm not interested before knowing the details. So it's good that people go through the grind, okay? So I don't think, unless you've been programming for all the time, even when you're young and all, I think people have to go through the grind, okay, of doing really painful sometimes to an onlooker programming tasks when they are actually eking out and grinding things away because all of that in the future will just get internalized and in your mind gets inured to it so that you're not bothered by it anymore. It's very important not to be bothered by the details if you want to look at the grandeur. Okay, anyone who is bothered by the little details in life is never going to have a good time in life. So if you want to look at the big picture, you got to first forget about the little details. I don't know how I got started talking about that, but that's how it is in programming too. But it's not that you are completely ignorant. You have to look at all the details to know what it's like, all the libraries and how they work. Basically, you got to be in a position where if you don't have to write the GDL or some library that you're going to use, maybe even the vector class, who knows, right? Or some graph class that you have to write for some application. Maybe you don't have to write it, but you should be in a position to say, well, you know what, I don't have it, and I got to write it. So if you're in that state, then you're best position to say, okay, well, you know what, now I can just get someone to write it or use a trusted module from somewhere because I don't care so much. But what happens many times is that people just use, well, especially the non-CSE programming crowd. There's a lot of these people. Because you can get things working inefficiently, but it works. And a lot of people pay money for it, okay, even if it's built inefficiently, because you can throw in something that is going to use 5 times resources or n times the resources, quadratic complexity, people have to wait, all right, and all these things, which could be just avoided, cutting costs immensely, just by clever engineering and proper programmatic thinking, right? Some algorithms, fundamentally inferior and superior algorithms in terms of runtime and resource usage. But you see a lot of that implemented right there, even today, right? If you walk out on the street and you look at traffic meters and how these algorithms work, many of that is really inefficient. And people are, tolerant and we work towards, work with it. But there is no reason we really should be. If you do these things right, then you don't have to worry so much, yeah? That's how we got started talking about that. But definitely you got to know all the little details. That is why this time in CS2A is like super valuable. So nobody should think of CS2A as a way to, it's just a stepping stone to 2B and a stepping stone to 2C, and then we got algorithms qualification. That is the wrong way, all right, to think about this. CS2A is actually the most important part, because here is where in your career as a computer science student, here is the only time you get to look at the little details and actually just internalize them. So you don't have to worry about this. Now you can look at the bigger picture, because the bigger picture is much better. And but most people don't get there. Okay, especially I think people from other majors who are doing computer CS2A for the credit, or saying, well, this is what programming is. They don't get to see it. They'll only see the little details and saying, okay, well, if I do this enough, I'll just not be bothered by it anymore. We'll get someone else to do it. But that's just getting lost in the detail. So that is why I think that people have to stick it through a programming course. They have to go through the end, and in the beginning, not dismiss CS2A time as something that you just need to get over, right? So, or crunch it into like a summer term, or just do these things really quickly and get through it. That is the wrong attitude, because you won't get a chance to actually marvel at the little detail after that. And only people who actually know how these things work can actually put together a proper solution, knowing, well, you know what, I don't need a data structure that takes quadratic time here. Maybe that's the best you're offering me, but I don't need it, because I can use an n-log-n solution here, which is uses less resources and is more time efficient. So, but those are things that you would not know if someone just gave you a black box and says, without any time guarantees, says this is what it's going to do, right? We should be able to say, this is what this is how much I'm paying, this is what I get, all right? Even if it's free, yeah, because ultimately it's your time and your effort and your mental cycles. So nothing is really free if you look at it that way. So if should you consider an inferior product and think about it for 10 minutes, or do you have a real trust in a different developer that to give the best solution? All of those things are really important, and I think CS2A really does prepare students for it. I am offering CS2A, I think, next quarter also. So please tell your classmates, and it's a spring quarter enrollment should open in, I think, next week or the week after, maybe. Early enrollment. So please tell your friends and so on. Well, not that it's going to be because this is my last quarter here. Even if there's only 2 students, they'll still run it at Foothill. Hey, the guy's going to retire, why cancel a class and do crazy things, because canceling a class, getting to another class, another section, yeah, that may be okay, but the adjunct who had the section before, they'll lose it. But I'm happy to run the class even with 2 students, but tell your classmates and other people to enroll next quarter. That's the last offering of CS2A. And it'll be fun. Really, the more students there are, the more fun it is. Okay, like this class is actually really cool. In the past, I've taught classes where there's like 5 students. Well, CS2A, not talking about 2B and 2C, understandable in these discussions, but 2A, 5 students is ridiculous, right? And well, technically speaking, only the students who are really committed and want to learn should do the class. But that's not reality here, right? So everybody wants to do it. So yeah, it's going to be open, and soon please enroll in CS2A next quarter. That will be the last thing, and we'll have a lot of fun, I'm pretty sure. And you guys can go on and do my CS2B at that time, okay? And welcome to my CS2A lectures also. And I will be happy to attend your virtual meetings also, right? And next quarter. So
the midterm exam, when is it?
It's on Thursday from 6 p.m. to 9 p.m. Why is my phone not
this Thursday? This Thursday.
This Thursday, yeah, the day after tomorrow.
Okay.
So that's why there's no class. Yeah, don't miss it, okay? Sophia, you didn't know this?
No, I know
Okay, all
it
right.
was
Thank
an
you for
exam,
coming
but
to
I
class.
didn't know when.
Okay, there's this Thursday 6 to 9. Please, someone come and confirm it, okay? I think it is 6 to 9.
So it's like, should we log in?
Yeah, log into Canvas and go to assignments or maybe quizzes. You'll find it there.
Okay.
Yeah,
And
same as the data representation quiz, except it'll be more questions from the first 6 weeks or 5 weeks. Everything up to objects.
mhm.
Yeah. And someone pointed to the CS Club modules. They're fantastic, okay, because they're mapping exactly one-to-one with lots of stuff that we're doing. So you have to read exactly 6 modules up to the midterm.
Which modules?
Hmm?
What are you?
Oh, modules? Someone shared it on Reddit. It's the CS Club modules, okay? CS Club.
Okay,
It's on Reddit.
I will
I
check it.
saw definitely someone shared it. Yeah, maybe in 2B or 2C, but it's all the same. So just go. Yeah, there you go. Andrew just put it on there. Yeah, please do go to the modules or go through the modules if you can. They're very comprehensive. Michael Losef, who used to teach this class before I joined, right? He retired when I joined. And no, I'm retiring, and Lynn Johnson is going to be picking up CS2C. And Lane has done every single quest all the way up to 27 red quest. Okay, he actually dogged everything, and he also prepared some really cool videos that I've linked into our specs. Okay, and he's a prof in CS computer science, so I've had the pleasure of working with Lane before many times, and I am happy that he'll continue to teach the C++ sequence.
Excuse me, the modules is posted that it's also I saw Java. Is this
No, it's C also. You just have to poke around. There's a bunch of controls there.
Ah, yes. Ah, okay, now I got it. Okay.
It's all there. So Michael used to teach CS2A, C++, and he prepared those modules. And I taught with them for a couple of quarters. Then I realized that he has put a tremendous amount of work into it. Okay, all those program fragments that you see, he has actually run it. And not on online GDB, right? He ran it in his compiler, got the output, and prepared these things, because I've noticed little bugs too. And in the code, and you tell him, and you know exactly where it is, and he knows. So he's run even all the programs all the way up to CS2C. He's run the programs, and they're very nice. And the thing I like about them is that they're perfectly chosen topics. Okay, so that is why there are people on the Reddit who say, well, I didn't have time for it because I was solving lots and lots of lead code problems. Okay, or solving all Euler problems, or all these things. Now, here my recommendation is that should be your second priority. Primarily, you should follow a guided path created by a professor, because there are so many problems out there. Many times newbies cannot distinguish between 2 problems that are basically doing the same thing, and there's not enough information to actually distill out of them together. Okay, so this problem has been studied by computer science professors many years. And the sequence of topics that you find here will probably be the same. If you go to Stanford or Harvard, many of these places, if you go to introductory, this course, you'll find the sequence of why is that? It's not like that everybody copied the same thing, but in a sense. But the structure has emerged because we know that on average, well, this is my theory, but you can test it, right? Because I think we have found through experience that these topics are the ideal topics for students to jump between, right? Meaning that you can be taught this topic, and then you will be able to self-teach all of that, and then we pick up again and take you to the next jump. So all of these topics have been chosen. Whereas if you do leak code and things like that, you can solve 1,000 problems around here, but they'll all be here. Okay, so they're not, these intervals have not been picked carefully enough. Okay, even in CS2C, some of the problems we've they're in the book and all, but we actually omit, right? But it's much harder to omit problems in CS2C. 2A, it's okay, right? 2A, 2B, even you can say omitted. You go read by yourself. Yeah, no problem. Okay, CS2C, we cover so much material that that some of the material I think is not a realistic ask for professors to say, students, go and learn it by yourself. So you either have a choice, you got to crunch everything down and teach things with fewer resources, or omit certain topics. That's a real challenge. But I've never had to face that. In a roundabout answer, I've never had to face this, because this sequence of topics is actually perfectly chosen. We've omitted a few topics, which I would also have omitted, which are easy for students to learn on their own. But that, you'll find in all, after you hit 2B, I think that is what you'll find in all of the higher level courses. They won't teach you everything because there's simply so much to teach. But it is important that you follow some structured, some pedagogical research into it, saying, well, these are the only things that the student has to solve to get a full mastery. But they should be spaced out like that, and that's what's not missing, I think. From the, you can go and solve 1,000 leak code problems, but still not be prepared for a tech interview. Because they may all be, doing very similar things, so not giving you a good overview of the whole thing. Whereas you follow this would be cool. So do all the way up to red, okay? Red, even though I'm not offering red anymore. The CS2C. I'm pretty sure I'll be on the forum. Okay, this is just on my phone, regardless of where I am, even if I'm not in the States. I just need internet, and Reddit is there, so I'll be responding to all of you guys when you're doing red, right? Even if it's not next quarter. So, and I think I'll just keep the questioning system going. It's for at least this year, not a big deal, right? So please go ahead, and I would be super happy to see, continue to see you guys finish this track. Yeah. Okay. All right. Anyway, so again, why doesn't someone pick up the screen? Well, why don't we do this? Okay, why don't we do this? So last quarter, last class we started to write this, swap. No, not swap. What is that? Shuffle. Yeah, shuffle program. And then I said, oh, it's corner case, and leave it up to you guys, homework. Okay. And Sumit, I think, was the only one who fixed did anyone else fix the shuffle code and posted? Sumit did, I think, for sure. Who else? But I saw a bunch of people post the versions of Unfumble. Byron, you did too?
Yeah, I did from the Tuesday class.
Yeah. Oh, no. Did you post the shuffle, the corrected version of the shuffle? Yeah. A few more people then, right? So there's you and Sumit. I'm pretty sure I saw a couple more links. Nobody here in class? No?
Submitted one.
I don't know. Maybe I saw a few more. But anyway, what I thought we'll do is let's just go ahead, forget about the link and all these things. We'll just go ahead and create the shuffle program. Because it's a good algorithm, right? Very simple algorithm. This is what you would do also. If you were given enough time and say you got to shuffle these things, I'm pretty sure in a day you'll say this is the best way you can do it. Okay. So again, the other thing to do with all these computer science concepts is that it's very tempting to just, for given a problem, to say, what's the solution? I'll just Google it, or, ask ChatGPT, or ask someone, or ask, mom or dad or brother or sister, cousin. So there's so many sources where you can get the answer. So you got to be really, really careful to say, well, is it a life or death problem, right? Meaning that not knowing the answer, is it going to kill me, or is it serious? If not, you should not ask anyone. Okay. So just ask that question. Maybe you say, this is a tip from the prof this class. Okay. Don't ask anyone the solution for anything that is not going to impact your life negatively, right? If you think it's just a curiosity, then it is your curiosity. So you just collect these curiosities, make a book of all of the curiosities that you never solved. Okay. And maybe if you never find the answer to any of those, you can publish a book, a list of 500 unsolved curiosities. Okay. And that'll be viral. Okay. So everything that you are curious about that is not going to kill you, just make a note of it, and don't ask. Okay. Because I see even, looking at past Reddits and these things, just avoid it. Okay. And this certificate is not worth it, or the A+ that you get by getting answers and things like that. Not worth it. What do you get? The certificate is worth less than the knowledge you'd get if you didn't look up the Reddit and try to come up with the answer, even though it is like 5 days. Okay. So in 5 days, you got something that you give up the opportunity, and because just by answering, asking and getting the answer in a couple of minutes, and you just destroyed the 5 days worth of the aha moment. So anything that is, unless you're going to die by not knowing, please ask that question. the CS2A razor, ask that question, right? Anything that you have to decide and say, is it going to kill me? Right? If not, you just shelve it and say, well, you know what? We'll wait for it for my mind to noodle that for a little longer. Let me go and take care of my garden or something else to take my mind off it. So I think that actually might work great for programming in CS2A, B, and C, all the quests. Because if you look at all, you shouldn't look at all the Reddit, but you can look at all the reflections. Okay, most of the reflections say the thing that helped me most is not asking other students, but actually stepping away from the computer and going for a walk. Crazy, isn't it? Because when you go for a walk and come back, you're actually looking at the problem with a different perspective, right? So the detail that was actually grabbing your eyes and your mind without letting go, saying you can't look anywhere else because here's where the problem is. Because that's what all the programmers feel when when they think they have a hunch as to what the bug could be. Okay, that is the most dangerous state of mind for a programmer. Okay, so if you have a hunch and you haven't found it in a few minutes, or it's not getting stronger and so on and so forth, you should basically take a break and go away, because those things are basically grabbing you and preventing you from looking at other places. So so this is what all the students, all 4 years, okay, for 4 years, every year, every quarter, students have said that this is the reason, this is how I solve the quest. More so in 2B and 2C. Say, I just go for a walk, and then when I come back and I look at it, I got the solution. Okay. And it's incredible. And it's just, they just look at the problem in a different way, and we need that space. So please take that, and don't ask, don't ask for the solution, but you can ask for, give me a different perspective or something like that. You guys are doing fantastic. Okay. Actually, I think 1, 2, 3, 4, 1, 2, 3, 4, 5. So there's 20 students here. There's 6 missing. Okay. I think that's okay. It's reasonable. Thank you so much. That's 20 students is actually the most I've had. Well, no, I've had more. But this is good attendance for week 5. So thank you very much. Okay. So I actually remember most of you guys. So even when it comes to participation grades and so on and so forth, I can remember. So who was there in class and who coded and everything. So take this opportunity. And even when you're coding with your classmates and so on, you just interact, and I think it'll be much more fun altogether. Okay, so how about anyone today? How about who was going to code today? By the way, was it Enzo? Was it you? Do you have a Mac or a PC? I keep forgetting.
I have a Mac, and yeah, I was one of the people who's gonna
Okay,
code
why
today.
don't you just yeah, why don't you share the screen, because you've only shared it once in the past, yes?
Yeah.
We'll get you out of the way. It's a mirror. You coded, no, you only coded once at the end of last cycle, yeah? All right, so we'll all right, so Enzo is the from first person to start, I think. Did someone else code last class other than Mir? Hey Mir, who did you pass the code on to? Huh?
I also coded.
Agnes, you coded last class?
Yeah, a little bit.
Okay, all right, so maybe Agnes did. All right, maybe you could just do alphabetical, but that's okay. All right, Enzo's got the screen. Just get rid of everything. Just get rid of everything. So say, put comments and say class code for today's date. You can dismiss the ad and then make the blue column too, so it's easier to read. Yeah.
Oh, like
Yeah,
is in
no, okay, delete everything, and then dismiss the blue part. Dismiss the blue.
All right, I'll just,
yeah, Control A and delete, and then put comments at the top. This is the usual stuff. We'll do this every class. Okay. Class code for what's today's date? 11. Is it raining right now? Is it raining? As Mir, you're on campus, right? Is it raining outside?
Not right now, Professor.
All right. Okay. Well, you tell me when you said you have to catch a bus and all, right?
Yeah.
Yeah. All right. So you tell me, or you can just go when you have to. Okay. So you don't have to worry about stopping the class.
All right, sir.
Okay.
I'll just send you a message if.
Don't worry. Okay. I know you are here, and then you just coded, so you won't get a chance for at least a couple more classes.
Understood, sir.
Yeah. So if it looks like the weather is going to be bad, you just take off.
Got it, sir. Thank you, sir.
All right. No worries. Okay. All right. So class code for 2/11/2025. Yeah. All right. So let's do the comments. Yeah, in the comments we'll say we're going to implement the the shuffle function. Okay. It's basically standard shuffle. Actually, someone said I use standard shuffle with a random seed. I don't know who said that. Was it you, Tristan? I don't know. Someone said that. Okay. Someone said I use standard shuffle in the unfumble game with a random seed. I forget the details of who said that, but I thought it was Andrew, or someone who posted the code anyway. So all right, okay. All right, so we're going to implement the shuffle function and in the process learn about parameter passing. Okay. Yeah. This is going to be a fantastic opportunity. Okay. This because we'll dive into a lot of these things. Okay. Yeah. Fantastic. Thank you so much. Okay. And then we'll do the whole thing in main. So say hash include IO stream, and then we'll also use namespace because it's just main.cc. Let me increase the brightness here. Okay. That's much better. I hope this, all of you guys show up in the in the video recording on YouTube, because I haven't looked at all of those, but I hope all of you show up. Okay, I selected side-by-side gallery. Okay. Okay, all right, and then using namespace standard. Thank you. Yeah, that's great. Okay, right. Space standard. STD. Now, this part, everybody should just do it like 4 or 5 times and get in the habit, because it's very simple. And we'll start every class with something like this. Yeah. Because we got a few more lectures, and we'll do a function called, we'll call it shuffle. Okay. It may complain saying there's another shuffle that included, declared from IO stream somewhere, but if so, we'll change it. Okay. So void shuffle. Do we want to make it void? No. All right. So let's make that return a string, right? And then the parameter should also be the parameter for shuffle inside, right? Should also be string space ampersand, okay? Ampersand s, okay? And then we'll put a comment on top of this function, okay? So go to 8, hit enter on line 8, and then start the comment saying, okay, this is going to randomly shuffle. Basically it's a pseudo hyphen randomly, because we're not doing srand. Yeah. So main will do the srand. We'll just assume that we'll just say, yeah, pseudo randomly, pseudo, eudo. Yeah. And then pseudo randomly, I thought it was hyphenated. That's okay. So shuffle the string as in place. Okay. String as in place. I actually put in place in uppercase. Okay. In place in uppercase, but put the whole thing in, right? Now, in parentheses, you can say, discuss why this is important. Okay. In parentheses, discuss why in place is important. Okay. Discuss why in place, because in place algorithms are really, really cool. And they're very important, because you can do all of the work without having to request extra space. Okay. You say, well, you give me a string, I'll build a new string and give it to you. That's a, low efficiency algorithm. Well, not low efficiency, but it's an inferior algorithm, inferior in the sense it uses more resources in a way. Okay. Even though you can't quantify it easily, because if it's not in place, it is asking for extra space to be created. Oh, you're doing this in ChatGPT? Yeah, all right.
Yeah, I mean, that's what I
yeah.
do during class. Like if I don't understand something, I just
This is great. Yeah. So in place is actually an amazing, because that is why sorting. Oh, it's just this guy sorted. Does ChatGPT talk about sorting? In place sorting. Yeah, there you go. Yeah, because sorting especially. People spend a lot of energy coming up with good in place algorithms. Okay, especially for sorting and permutations of strings and all. Because many times you can get an efficient algorithm, but it requires extra space, like merge sort. Okay, it has to take that extra space. But n log n complexity, meaning it takes a certain amount of time. Quicksort takes the same amount of time, but it doesn't require that extra space. So why would you use the more expensive version? See, these are the things that good programmers will know. Of course, you can use a library version. That's usually the most efficient way. But just because it's library, you can't just put your trust in it. You need to know that it's the library version uses an optimized version of quicksort rather than merge sort, right? But if you didn't actually do this and get into the details, you wouldn't know these things. Well, maybe you would know, because you can always go and ask one of these AI assistants. But still, the AI assistant can give you information, but to read it, digest it, and also appreciate the nugget inside the information that the AI gives you, right? And that takes the same amount of time in my experience, right, interacting with these AI bots and so on, in my experience, it takes the same amount of time as, working it out on your own slowly, because, it takes certain amount of time playing with the code to actually understand, get the aha moment, right? So even with code that is freely supplied to you, you can just get a freebie out of it most of the time. Okay, you can't say you can assume that it works because it's a trustworthy source, but most of the time, if you seek to understand it, you will probably take the same amount of time to get to the bottom of that code as a developer did. Maybe you do it in a more contracted way, saying 8-10 hours per day or whatever it is, because it's crucial for your product. But to get to the bottom of these things, you actually do put in the same amount of intellectual energy, right? So that, I think that's a, wild ass, guess or a hyper theory that I'm making. All right, the in placeness, it is actually a hugely valuable property of algorithms. So it is worth it to understand in place algorithms, which are usually more or less obvious. Okay, in place algorithms are less obvious why they work, but they work. Okay, and you can prove it. The mathematically or hand wavy or whatever it is, but you can prove it that it actually works, but it's not obvious. It's not one step like that. So those are the really cool things that you can get with in place. So that's why it's in. Well, you got to summarize this. I shouldn't be telling you this. You got to summarize why it's important. Okay. It also returns a string. All right. Now the third comment. It also returns the same string to be used in a different. In an alternate setting, in an alternate context, okay, in a different context or whatever it is. You can change the wording later on, meaning that it's going to change the string. But so, all right, we'll get to this, okay? All right, so go to, and we'll write the use case for it first. Go to main, and say string s equals, and say 1, 2, 3, 4, 5, 6, okay? That's 6. 1, 2, 3, right? Let's just do 1, 2, 3. Let's not be ambitious, okay? No. String. It's a string. 1, 2, 3. String. Basically, what we want is we're going to permute this, and okay, get rid of 1 comma and all, right? So it's just 1, 2, 3. A string. Yeah.
Like that.
So permute the string. We're going to turn this into 321, 231, and all these things. And then what is the total number of such permutation? We'll do a simple count using Unix tools, right? Because he's got a Mac, we'll just go to terminal and do these things. And maybe you'll get some extra goodies from the Unix side of things by doing this. It will usually be fun, okay? So not really relevant to CS2A, but good for CS programmers to know. All right, yeah, string. No. Let's do a loop, okay? So do a loop, right? So for size t I equals, everybody should be doing the same thing, okay? This is very simple code. You should be just coding on your own in online GDB, not in VS Code and all, okay? Yeah, exactly. All right, like so this part should be automatic to everyone, okay? Enzo is just typing the whole thing out. So size t I equals 0, I less than length, s dot length, and length is a function. You call it like that, I++, right? Now here, what we'll do is size t j equals. So here's what we want to do. For the first character, we're going to pick a random location from the entire array, right? It has to include the whole thing. So that's 0 to n-1. For the second person, you're going to go only from 1 to n-1, meaning that you're going to generate a random number from 0 to n-2 and add 1 to it. So that's basically what we're doing. So what we're going to do is size t j. Size t j equals I plus. Okay. Now within parentheses, we'll remove parentheses later after we see how it plays out. Okay. Yeah. Within parentheses, no, you're going to say rand open close. Yeah. Space %. Open parentheses now. You want to say s dot length minus I, right? S dot length. Now, here is some of you may be thinking, well, what is a function call? Why is he calling it 3 times? This is actually a very important point. Okay, make a note of this. This is s dot length seems to be a function call, which means that you shouldn't be calling it in loop and calling it repeated times in this loop and so on and so forth. But as it happens, s dot length just returns a constant member from the object that's a string, and the compiler will optimize it so that it's just a number. Okay, just like anything else, it's a constant number. So don't worry about it. Okay, s dot length is a function call. No. No, you should say, no, should we worry that s.length is a function call? Discuss in the forums. Okay, you can do some research in ChatGPT. Okay, or don't ask ChatGPT. Okay, I don't know. Figure it out. Okay, s.length is a function. Does it make sense to call it in a function, in a loop? Does it make sense? Yeah, discuss. Call it. Yeah, discuss this. Okay, and discuss this. Okay, all right. So you can do this in the forums. Okay, here size t j equals. Yeah, let's make sure that's correct. Okay, so the first one is going to be 0, and the random number is going to be from 0 plus some number. Yeah. Percent s dot length, right? No. Hang on. Yeah. I think we got the error. Okay, get rid of the take the minus. Oh no, s dot length minus I. Yeah. Okay, I thought it was -1. I'm so sorry. Okay, 1 sec. Okay, let me maximize the screen. Yeah, why was I left? I wasn't even using the, that stage manager area. Oh yeah. Okay, it's s dot length minus I. So s dot length minus I. So 0 to n minus 1. The first random will be from 0 to n minus 1, and then you're adding 0. And the second one you're adding 1, but it'll be from 0 to n minus 2. Because you're dividing by n minus 1, the n minus 2 is the biggest, right? Okay, so that works out. And the last one is going to be when it's 1. Okay, so rand %1 will be 0, and that'll get added to it. All right, so this you just have to do this calculation in your head, or you can do it on a piece of paper. You just have to make sure that when you're calculating the index to swap, okay, that works when the string is empty and when you've gone to the end. Those are the two places where most of this times it will be. All right, on the next line, you're going to say swap. Yeah, this is the other function we're going to write. Okay, open parentheses, and then in there you're going to say s square bracket I. Yeah, and then s square bracket j, second parameter. Okay, and then we're going to write the swap function. Okay, and then go above main, and we'll write the function. Hey, what's going on? One sec. Okay, wait. One sec. Okay, this for loop should be inside shuffle, not in main. I'm sorry. Yeah. I'm sorry. I thought we were in shuffle. Okay, all right. So for thank you, and size tj. Oh yeah. All right. Now after that blank line, get rid of 19. Get rid of 19. Line 19. We don't need the blank line. Okay. So that's going to. All right. There you're going to return s. Okay. All right. Now let's write the function swap above shuffle because it's being called. No, above shuffle because it's being called in shuffle. Before the compiler sees the call to it, we want to make sure. So void swap. Okay, now here this is the part that you've got to, right? These ampersands are very important. Someone said response, I don't know, I forgot. I saw a comment about the ampersand and I said, well, I should remember to fix or correct that. Then I don't know, I forgot. Okay, all right, yeah, all right, a comma, all right, and then char, yeah. No, you can't have S and J. You got S and T maybe. Yeah. No. Oh, I see. It's doing this autocorrect. Okay.
Yeah.
All right. So here, no, on the first line, you're going to say char space C. Char as yeah. Just call it x equals s. We're using x for a char, but it's only 3 lines, so it doesn't matter. Okay, on next line, you're going to say t equals s. On the next line, you're going to say s equals x. Okay, that's it. So now it's go to line 8 and hit enter, or line 8 and hit enter. Okay, all right, comment there. So in the function below, the ampersands, what is the why are the ampersands important in the function below? Okay, And then we need to put a comment on for the function itself. Okay, on the next line, we'll put a comment, right? Yeah, enter, right? So the comment should say, this function will swap the contents of characters S and T, right? In place, or, or by reference, or, I don't know, by reference, okay? I know, ampersand, why is the ampersand important? I know all these comments are kind of messy. I should have thought about the comments more. This function will swap the constants of S and T. No, you can discuss that in the forum. Yeah, okay, that's fine. Anyway, you can tidy these things up, okay? So this should swap, and then the shuffle is going to shuffle it. And in your main, let's do the loop to print. Yeah, that's where we started doing the for loop, and then we got carried away. Yeah, hit enter.
I had a question about
Yeah.
the swap. We are erasing
yeah.
the value in T here. So it should be, the first one should be S equals to T, because we saved S, but we haven't saved T. Meaning,
yeah. I'm so sorry. X equals T. X equals T. X equals T. Then thank you. Who was that, Sumit or Rahul?
yeah, Sumit.
Sumit, then thank you. X equals T, T equals S, and S equals S. All right, great. Then thank you so much. It wouldn't have worked, and then we would have spent like 10 minutes trying to get to the bottom of this. Thank you for saving the time. All right, okay. Now let's go to main, and then we'll do our big loop. Yeah. All right. Now, go to the line 39 and tab 35 and tab in. We'll call srand. We'll call srand. Okay. Srand. Yeah. Open parentheses, and then you're going to say unsigned within parentheses. Yeah, and then outside you're going to say time, open parentheses, null pointer. Okay, all right, semicolon. And everybody knows what it is. We're not going to comment it. And people generally know, programmers who read it say, oh, that's fine. Yeah, okay. All right. All right. So now go to line 38 and hit enter. All right. Now, by the way, when that's all right, 2 more lines and we're done. After that, I want to hear from everybody to make sure you understand all of that. Even places where I said, go to the forum and discuss it, you should basically say, I don't understand. Can you explain? Okay. So I'm happy to explain all of that. So, ampersand and passing by parameter, reference and so on. So happy to do that. If not one of you guys. Okay. So everything's right. So do a for size t I equals 0, I less than 10,000. Okay. No. Oh, yeah. Let's say 10,000. Yeah. In fact, just do 10 times 1,000, I think. Or just do 1,000 for now. I think that's enough. Yeah, I++. And here, you're going to say cout left shift. What is it? What do we call it? Shuffle? Yeah, S. You got to pass it the parameter S. Okay, and then endl after that. Okay, a semicolon. You don't need the curly braces because that's all there is. You just need a return 0 at the very end of main. There you go. Yeah, you can get rid of all the blank lines. Let's run it, and we'll see that we will make sure that we get a lot of these things. And then, size t I equals 0, not size t equals 0. You're missing an I. Okay. But it's all over the place. That's the only one.
Well, let me see.
Okay, all right. So it seems to be working. All right. Now, what I want to make sure is that we'll just make sure we'll do all the sanity checks once we go into the terminal and do these things on Unix. It'll be much easier. But before we do that, I want to expand the code. We'll just make sure that everybody is on board with the code. Okay. How about I give you like 2 minutes while I go and get a drink of water? Okay. Just go over the code, make the code window bigger. Okay, and then go to just shuffle and those two, right? Yeah, the top 2 functions are the important ones. If you can share, actually get rid of the console altogether, you can see all 3 functions, I think, including main. Yeah, all right, that's great. Okay, how about 2 minutes? Everybody pour over this code. If you have any questions, you can ask me or someone. Is someone in class able to explain this? If a question is asked about the ampersand and what, actually, you should also do an experiment. Okay. Now, if you get rid of the ampersand and S and there in swap, you get rid of the ampersands. Yeah, get rid of it. Now, if you run it, you've broken the experiment, right? It's important to break these things. Is it all the same? There you go. The shuffle didn't happen. Yes. So you should break these things and say, well, what happens if there's one ampersand and one is missing? What happens if both ampersands are missing, right? What happens if in shuffle the ampersand is missing? You can do all these things, play with it for, how about, what time is it now? Okay, it's only 7:09. Okay, how about until 7:15? You guys look at the code, understand it, experiment, right? So just because Enzo's got the code, maybe Enzo's going to pass it on to someone else. Okay, and Agnes coded. Asmita, did you want to go next?
Yeah, I can go next.
All right, okay. Do you have a Mac or a PC?
I have a PC.
All right, how about we go to someone with a Mac for now, okay? Because I was kind of relying on the terminal. Does
Sounds
anybody
good.
have a Mac? Who wants to go now? Otherwise, Enzo will drive, okay? Hey, Varsha, you got a Mac? Sumit, yours is a Mac, right? Is it?
Yeah.
Do you want to pick up the code from? But before Sumit does, anyone with less experience has a Mac, that would be the best, okay? Anyone who was a fresher to CS2A, not coded a lot, except the quests, okay? Even in quests only, quest 4. So those are the kinds of people who should volunteer first. Because if you've coded a lot, you can stay on the sidelines and watch. No, nobody else has a Mac and new to coding. No. Well, what about Andre? You got a Mac? No. Fatima, you got a Mac? Fatima, are you there? Jesse?
I have a Mac.
Do you want to code next?
Yeah, I can.
Okay, see, I don't like this. Okay, I got to go over and ask each and one of you, and then when you're finally my finger points at you, you say yes. No, that shouldn't be the case. When I say who wants to go next, everybody should jump up and say yeah, right? Otherwise, what I take away from that, my feedback is that this class is not fun for you. You're just doing it because you got to do it. Okay, that's not the class I want to teach, essentially. Okay, I want to teach a bunch of students who are eager to learn and say they'll jump at every opportunity, right? So you shouldn't wait for me to say go next and so on and so forth. I would like to see all of you, right? Already you're coming to your lectures. That's also fantastic. All right, so I should thank you for that. But you should jump at these opportunities and be enthusiastic, because being enthusiastic about this is the only thing that is going to save your ass in the future. Okay, not picking up a certificate or making a name saying I attended all 24 lectures. That's pointless. So right, you attend the lectures in order to get a chance to be jazzed up about this whole thing. Okay, so you should take that opportunity. There's not a whole lot left. Half the quarter is gone already. So you take the opportunity and start, just practice enjoying computer science with everybody. Okay, I don't think you get this opportunity in all of the classes, even if you enroll in other classes elsewhere. Okay, so this is actually very unique. The kinds of community and the students that are coming to this class, they seem to be a very unique mix. They're not like competing with each other and so on and so forth that I've seen even in my previous classes when I used to teach on campus. It's just like 4 years ago, right? Since then, I've been teaching mostly, except last year I taught on campus. But some of the older classes, students are competitive, right? They don't talk to the others, and they are, they don't. But here, it's all very different. Everybody's helping each other. So that is the way to do computer science, right? Because it's fun. Everybody should be having fun. Otherwise, you look at it as a chore. So that is the last thing a computer science teacher wants, is for you to look at computer science and say, well, it's a chore. No, then the computer science teacher has failed. Because all I'm trying to do is get you jazzed up about it so that, I don't have to hang around, right? So after 6 months, 6 weeks, you're off and you're doing your own thing and you'll be fine. And that's what every teacher wants, is to just make students independent so that they don't have to be behind them every time. So you can please your teachers by just being diligent and being jazzed up about the subject. Right? All right. So 5 or 10 minutes, and then I'll be back, okay? And you should be talking and coding, experimenting, okay? And who's got the code? Yeah, Jesse. Right, so you should be telling Jesse, hey, Jesse, let's try this, okay? Let's try without the ampersand, and then look at the behavior and say, hey, why is this happening, and so on and so forth.
And she checks what time I got to work, and like it's actually insane. Actually, that's looking crazy. There's no way. No, so basically, like she didn't even call me. She
You're
called my
muted.
mother.
Agnes. You're
I want to hear the
unmuted.
story.
My bad, sorry.
Do you guys have the code now?
Yeah, I got it. I'm gonna share. Okay, can you guys see my screen?
Yep.
Is there anything that people don't understand here, and we can mess around with a little bit to maybe better explain it?
Could someone kind of explain like line 13?
Okay, sure. So you see how line 27 is basically like you have S of I, which is basically the thing that you start with, like the first thing that you're swapping with something else. And then S of J is the thing you're swapping with. So the ampersand is basically saying, hey, we're actually going to directly edit like these characters in that string rather than making a copy and editing the copies. And so if you remove the ampersands, what happens is when you try to return S and print shuffle S, the original doesn't actually get changed. So in this code, the way we have it, it wouldn't work without the ampersands. But if you were to use ampersand, remove the ampersands and actually have C out inside the swap, it would still work as intended. Because we're then using the copies instead of needing the original. Does that make
Wait,
sense?
just to piggyback off of you, Enzo. If anyone wants to know, basically the ampersand is like the memory address. So the reason why you're directly changing like the S and T themselves instead of like a copy is because you're accessing the memory, which is what the ampersand is for. But yeah.
Okay, that makes
So,
sense. Thank you.
when you put the n% there, it's like it's a memory of the S.
Yeah. So like in C++, every single like object, like a character, a string, an integer, it runs in your RAM, right? Your random access memory. And then when you put like the address, it basically like directly manipulates that specific object rather than making a copy like it usually does. Because that's the standard behavior for programming, right? Like when you
So,
when you manipulate an object, it creates an object. I mean, it creates a copy, sorry, and it manipulates that copy.
and it creates an object with a different address in the RAM, or how does it do it? And if I don't put it, if I if there is a copy, so it's a different address then.
Wait, so are you asking like what happens if you don't put the ampersand?
Mhm.
Yeah, I'm pretty sure it does a copy. Like you know how in Python,
But
well, I don't know.
it's a different, like maybe it's like it's a different copy with a different address in the
Yeah, different
memory.
address. Different address if you don't put the ampersand. If you put the ampersand, you will directly manipulate the object itself.
Yeah,
No copy.
like if you don't have the %, you're basically like creating a copy of the like that variable, and then after that changing that. So it doesn't really change the original variable that was given. It's just like creating a new one and changing that one.
Is this for safety reasons to have like a copy every time?
No,
Um,
it's just like so you could like change like what is like given what like is given to the function instead of like I guess like yeah, doing nothing.
really, for me, I'm not sure, but I think it's for safety reasons because, um, I mean, usually like you don't want to directly manipulate the object because I think there's like some lower level stuff with it, specifically related to like memory. But like if you guys know Python, like for example, if you're getting a sub list out of a list in Python, right? You're actually creating like a new list or um wait, where am I going with this? Wait, I think I'm pretty sure it's related to safety. I'm not sure, Zachary, but when you say like the address is just for wait, can you repeat what you said again, actually, Zachary?
No, I was just thinking like, okay, so if that's the default, like to create an address, like a new copy, so you need like double the space every time. So maybe why should that be like, and not going directly to the when you call a variable to go and change the variable, and if is
Yeah.
this like for safety or
Yeah,
what
yeah,
is the
yeah,
thing
Sophia,
behind?
because that's very interesting because I never really thought of it, right? Because like I think for many other languages, the standard behavior is that you'll create an object, like a copy of the object whenever you do something to that, right? But I've never thought about like, oh, like why is that? And I think it's more related to safety, right? Because yeah, you're right. Like whenever you're making a copy, you're using more memory, so you're actually like using more resources. And I think that's
Yes.
why C++ is like so sought after, right? Because for the majority of the time you want some safety, but when you know for sure, like when you really know what you're doing, you want to like be able to, control that address, save up some space. I think the safety train of thought is very reasonable though.
Is
Another
this because
pattern.
this is faster? Like maybe because that's what I was thinking. Like maybe if you can directly change the original, like you get faster to the maybe I don't know. I was just thinking like maybe that's the advantage of the C++, like in
Yeah, it's more
comparison with
efficient. It,
yes, it's more efficient, something like that.
yeah.
That you can do this instead of going through the copy and do the stuff,
Yeah,
maybe.
because if you had like, I mean, when we did the vector of vectors, like if you make a copy of that, that can get really expensive, especially if there's like tens of thousands or millions in the vector of
Mhm.
vectors. So doing it in place is considerably more efficient.
Okay.
So in
Yeah,
other
but
words,
also like I feel like the reason the default behavior for C++ is not always just in place. Like there's I think it makes sense like for safety reasons, right? Because maybe you will like have an infinite something and then crash like you can crash like RAM, could crash like CPU. So I think yeah, I do think it is for safety reasons.
so in the shuffle function, I don't see any reason for the ampersand or for the parameter to be passed in like that. So is that for performance only? Because we're returning S at the end.
I mean, I think for this class, he's trying to demonstrate like in place, right? So I mean, you don't really have to do this for like a simple function like this, but I think he's just trying to teach us about like in place, which is why we're passing in like the memory address for this, because you really don't need that for like to accomplish the goal of this, right? Which is shuffling a string. But I'm pretty sure it's just for demonstration purposes for in place.
Well, if he didn't return S, he would have to call the function before, and then he would have to see out S. I guess that's an extra step, maybe.
Wait, what do you mean? Because
Well, if you don't return S, it's just like a void shuffle, and that uses ampersand S. So you would call shuffle S before the for loop that does it 1,000 times. So then it would do the in place shuffle, but then like it wouldn't really work because I think it needs a return. How would you wouldn't be able, you'd have to like call it in the, I guess you'd have to call it in the for loop and then see out using S instead. Right. But then that would change. Yeah, it kind of makes it. Yeah, you think you need the return.
is that related
I,
to the
I
ampersand
didn't get
S?
it. I didn't get why this in place is important here.
It's I don't wait, did you don't get why like
I
address?
didn't understand what Byron said. Like, I think we are talking about the shuffle function and why in the shuffle function there is an n% in the s, so it changes the string itself,
Yeah,
right?
that's why.
That
Yeah.
was the so I didn't understand why this could be of importance here.
Okay,
I don't I don't know if
is that a question that I can answer, Sophia?
I don't know. Byron was explaining that, but I didn't understand.
Well,
I didn't
what was
understand
the
it.
question? I didn't hear the question. I can
So we were talking about the changing
10%?
the yes, and yes, we went through the swap function, and then the shuffle has also changing in place. Like
Yes.
you put it, it's important. I don't understand why this is important.
Yeah. Okay. Yeah, certainly I can weigh in, and I didn't hear Byron's explanation, so hopefully I won't be biased, and so I'll give you a different take. Maybe one of those will click for it. Not just you, anyone else who may have the same question. Okay. So what we can, in fact, what we can do is we could potentially just develop. You can do this as an exercise too. You can develop a version of shuffle that does not take the ampersand, and it only relies on the return string. Meaning you give me a string, I'll shuffle it, and I'll give you a new string, but the original will be untouched. Is that what is that is the alternate way, isn't it? Those are the two ways.
Yes.
And you're asking what is the use of doing that, that ampersand thing and doing it in its place? Yeah?
Yes.
Okay, very good question. Now, I think the best way to answer this question is instead of a string, if I gave you a vector of integers, the same algorithm will work too. Yes, because you just
yes.
Yeah. Okay, suppose I give you a vector of 2 billion integers.
Okay, this will take too much of space,
isn't it? It's going to allocate new memory, and allocating a vector, even though it is a simple data structure, it takes a lot of. So that's where you can pass by.
Okay, the same is true for swap function as well.
For swap, I know for swap, I cannot think of another way that is as elegant as how can you do a swap without taking a reference parameter? That's a challenge. Okay, so for everybody, not just Sophia, okay, can you do swap? Can you write a swap function that does not take a reference parameter, doesn't use objects and all? Okay, so you can't use anything that you haven't learned so far, like objects and other things. So you shouldn't do that. Make sure the problem statement is very clear so that you don't have to rewind and watch the video. Can you write a swap method that'll swap two objects, but you're not allowed to have reference parameters? How do they do it in Java? Yeah, in Java they'll have to. You have to do it in you have to make an object, I guess. How do they do it in Java? Oh, I see, because it's a pointer. Everything is a pointer. I see, you have to pass two integer objects and then it'll swap the contents, I guess.
I used I appended the character to the string and then erased it in one of my
Java?
No, I'm using C++. I posted five different ways of.
Oh yes. I saw that. You return the string and then you are not doing the ampersand. You are just returning the value. Yes.
Yeah. And I'm using the same string to store it temporarily and then erase it.
Yes. Okay. So there's Sophia. You can actually find the answer to your question in what Raphael posted. I actually saw that. I forgot. He posted a version where you weren't take the ampersand, you're actually creating a copy and then returning a new string. Is that right? You're returning a new string.
Yeah, well, I use different ways. I was just experimenting, and the one I was thinking of now, I'm using the same string, just appending the character temporarily to the end, and then erasing it.
I see.
That was one of the versions.
Yeah, I actually remember your post. You actually you had 5 or 6 different versions of the swap or something like that. Yes,
The jumble, like
of the jumble. Yeah, yeah.
Yeah.
Yeah, it may well be worth read. So please reference that. But this is a thing to think about and say, can you implement a swap without using reference parameters? The answer may be no. Okay, but it's important to try it out and convince yourself that it's no, and then write about it. So I think that'll be an interesting thing. All right. Okay. So and Sophia, your question is answered. I hope that the in-placeness is important. In this case, it's not so important, but technically, if an algorithm can be done in place, it'll be faster and more efficient in terms of space.
Hey, Professor.
Hey, Professor, I have a question.
Sure, go ahead.
So the default behavior in most programming language is not in place, right? Meaning you're always creating a reference object.
No,
right?
well, first of all, I shouldn't say, when you say most programming languages, that I think has different connotations in different circles, right? Out for the lay people, most means JavaScript, Python, Java, and those kinds of things. Yeah, and because they're all, and I think there you have, you give me an object, I'll give you an object back. They're not focused so much on efficiency. Let's put it that way.
Right. So
machine language in C++, this is how you do it.
So is the reason for like most times, because in order to manually access like the object itself at its own address, we need to do ampersand, right? But is the reason why like we have to, put the ampersand to like directly access the memory, is that for safety reasons or is that for another reason?
Well, all right. So the ampersand here is not the address. So maybe
Well, it's getting the address, no?
No. All right. So I saw your post when you said the ampersand was, and I forgot who it was. Okay. And I wanted to correct that. Yeah, I think I mentioned this earlier in the lecture. I wanted to correct that misconception. Here, it has allusions and it's related to the ampersand for address, but it's not. Okay. What it means is that we put the ampersand in front, it is syntactically different. It says to the compiler, this guy is going in original form. That's what it says to the compiler. So the address being passed over is not sufficient by itself. The address needs to go, and also it needs to supply other information like a Boolean flag saying this guy is to be modified in place or a constant. All these things need to go with it. So it's not just passing the address, because if you're passing the address, it may as well be a pointer. Yes?
Wait, I'm kind of confused now because you're saying that if you put the ampersand, it's not getting the address? Because when I tried it, I did.
The thing is, whether it's getting the address or not is hidden from you. What you should think of when you put the ampersand, when you write C++ programs, is that the ampersand in front of a variable means that variable is going actual, okay, reference. You don't know whether it's passing the address or whether it's storing it someplace and saying that's stored by. That is hidden away from you. We should not be thinking about, well, you know what, it's doing it because it's passing the address. Does it make sense?
Kinda, but not really.
No. When I say here is an ampersand, that means you're going to modify this actual object. I'm passing the address of the object. Okay?
Yeah.
Okay. If I say that, I'm actually giving you more information than you need to know. Right? But that constrains me because I have to pass the address. But I don't want to pass the address. I may actually store it somewhere. Okay? And then send information saying, well, you know what, go there. And that's where you need to modify it. And after you modify it, I'll do some magic to transfer values from there to this original, and so on and so forth. I could do things in many different ways. So you don't know exactly how it's doing. It's the ampersand works. Well, you're saying it uses the address, but it is not important to us that it uses the address. What we need to know is that the original is going through. In this context with the ampersand and parameters, we should stop thinking about it as the address of operator. Generally in C and C++, if you put an ampersand in front of a variable, it gives you the address of the variable. Yes?
Yeah. That's
okay,
what I
all
was...
right. Here we should stop thinking about it like that, okay? And maybe it just takes getting used to. We should stop thinking about this as sending the address, because sometimes you're going to sending the actual address of a variable. So you're going to be sending a pointer to a variable. But in the called function, I'm not using it like a pointer. Okay, so if I send an actual object, I won't be using it as a pointer. I'll be using it as the actual object. Well, this will all make more sense to you when we cover objects and learn about how objects are sent in C++. Yes?
Wait, but a pointer is just like a variable that points to the address, right? Like if you put like a star in
Yes.
front.
No, a pointer is an address. It's not it's not a variable that points to an address. A pointer is a variable that holds an address.
So a pointer is an address.
A pointer is an address.
Oh, I thought like a pointer was like it points to an address.
No,
Because
a
like
pointer is a memory address. If I have a variable called p and it has a value, it's a memory address. We shouldn't really be talking about it because taking
okay,
time away from this class. Well,
yeah,
we'll get opportunities to talk about this later on. Okay.
okay,
But
yeah.
for now, I think we shouldn't confuse ourselves saying, well, this is what it does. We should basically look at the ampersand, and we haven't talked about addresses yet. Okay, so forget about addresses and stuff like that. You shouldn't be talking about that at all. So we just look at the ampersand notation for parameters and say that means the actual object is going through. We don't know how it does it. Internally, the compiler might say, I might do it using addresses. But maybe it's not doing it using addresses. I don't know. But the thing is, we shouldn't know. Well, we may know, but we should pretend we don't know that. We just say, okay, the actual object is going through, right? That takes a little bit of getting used to, maybe a couple of days even, of writing, 6 different versions of the code. But that's basically what it is, okay? So the ampersand means the actual object goes through. And obviously, I think you've experimented with, getting rid of the ampersand and seeing it doesn't work and so on and so forth. Yes?
Hmm.
Do you have any other residual questions for me? Okay, before I want to take this to the next level, because what Jesse will do is copy this whole thing and go to Mac terminal, yeah, and then we'll run it in terminal, and I'll show you some stuff that you can do to, with this code on there. Okay, but before we do that, is everybody okay? Do you have any questions at all? Any residual questions? This was
Professor,
actually fun. Okay, I had a great discussion before with you guys because you brought up these questions. Even Andre, when he asked about, even though we talked about pointers and stuff that is going to come, but it's still fun, when students ask questions like that, saying, "Oh, I'm confused about this. I thought it was an address." Okay, and it's a very common, confusion to have for C++ students especially. Okay, maybe not before week 6 because it'll be taking time away, but it's all fun for me to talk about, right? So you should cut me short. Okay, every time I get carried away and start talking about something at length which is not directly relevant to class, you should say, hey, get back to teaching. Okay, that's what you're paid for. All right. So if everybody is okay and no questions about this, let's copy this whole thing, and Jesse, just go to a terminal, share the terminal. Okay, and then
Can you guys see the terminal?
did you copy it into your clipboard?
Yeah, I did.
All right. Now I can't see the terminal. You need to unshare this and share the terminal.
Can you see it now?
Yeah, now I can see it. Okay. All right. You can in fact command minus one time. Okay, once type command minus. Yeah. Okay. Right. No. That's too many times. That's gone too small for me. Okay. I think this I can read. Okay. Now go to the temp directory. So we'll just do everything in temp. You can delete it, copy it later if you want. CD space /tmp. Okay. CD /tmp. Space. You need a space. All right. /tmp. /tmp. Right. This is a directory where anybody can create any junk. You don't have to be worried that you're creating junk there because the system will automatically clear things out periodically. Okay, so we're just going there, doing this in this temp directory because we don't really need this a lot. So go there with CD, enter. Now you want to see what's in this temp directory. You just say ls. For some reason, I have a vague memory that we have done this before with someone else, maybe Enzo or someone. And I said, oh, I'll walk you through the Unix steps for this. Yeah. I do an ls -l. It'll tell you all of the files that are currently in there. No, space, not space after the dash, space -l. Yeah, hit enter. All the files that are currently there. You see, and they're all created by, the person who logged in, Jesse, and then by root, they're all system files. So you don't have to worry about it. So what we're going to do is create our own file here with the contents that he just copied over from online GDB. Okay. So here, say cat greater than. I'm not going to go into the details of how this works and why this works, but certainly this is all, fruitful stuff for you to say, hey, well, we did cat greater than. Does someone who know Unix talk about this? All right. Say, why does it work? All right, and so on and so forth. And I'm pretty sure there'll be people here, Raphael, all these other people who also played around with Unix and say, hey, yes, this is what it does. Okay, and it'll be fun for you to strike up a conversation like that. Okay, and say shuffle.cpp. .cpp. All right, enter. All right, now paste everything. Yeah, paste everything you have in your clipboard. It is supposed to be raining. Mirror is still here. It actually says it's raining for me. On my phone, it says it's raining.
Yes, Professor, it's raining right now.
Oh, it is? Okay.
Yeah, I might have to leave soon.
Yeah, no worries. Okay. All right, but watch the video, okay? Afterwards, watch the video and try to code the same thing on your own also.
I will, Professor.
Okay, great. All right, now hit Control D, Control D. Control D. No. Control D, not Command D.
Oh, Control D.
Control D. All right, okay. Now, if you do an ls-l again, you'll see a file called shuffle.cpp. There it is. That's the file you just created and put it in there. You want to see what's inside that file? Just say cat space shuffle.cpp. Cat space sh and then tab. sh and then tab. It'll automatically complete, okay? Most of the shells do this automatically now. I hit Control L to clear the screen and go right to the top. How come your screen is like split in two?
I'm not sure.
Oh, you got two terminals like that lined up? Yeah, just have
I think
one.
so. How do I do that?
Oh, yeah, I thought you only had one when you started. How did you end up with two? Maybe there's
It's
a hard
because
pressed accidentally. Can someone look up how you can dismiss the other terminal?
I had
Or
put
just go to the other
Command D on
terminal and-
accident.
Hmm?
I had put Command D on accident and had to split it.
Or just drag it all the way to the top. You don't, yeah. All right, okay, that's fine. Don't worry, yeah, I think this is good. Okay, all right, now Control L to go to the top of the screen. Control L. All right, okay. Now if you hit enter, it'll show you what's inside that file. Okay, enter. Right, this is what's inside the file. This is what you pasted inside it. Yes?
Yeah.
Okay, now actually if you do ls ls space -l, or you can also hit exclamation mark ls will give you the previous command. Yeah, enter, right? Oh no, I see. Okay, see shuffle.cpp, it says 1131 bytes. That's how many characters you have in that file, right? If you actually count all the characters, including spaces and new lines, you'll see it has 1131 bytes. So that's the text English version that humans can read. Now we want to compile this. This is exactly what VS Code, Xcode, all these environments that you use, that's what they're doing in the background. We're just doing it by hand, but if we do it once, you know exactly what happens, okay? So you say G++ space. Actually, first hit enter, we'll see if it exists. Yeah, okay. See G++ space -o space. That's -o says this is the output file I want. Okay, space shuffle shuffle. Okay, and then space. That's the name of the program I want the compiler to create in machine code after reading my English version called shuffle.cpp. Right now you say sh and tab. It should autocomplete to shuffle.cpp.
SH and tab, you said?
sh and hit tab. Okay, right. Now if you hit enter, it will actually create the file shuffle. Okay, hit enter. G++ will compile it and create shuffle. Okay, now if you do ls-l again, you'll see one more file in the list and you'll see shuffle. Is there a file called shuffle? There you go. All right. And then on the left-hand side, you see the permissions, RWX and so on and so forth. It has one extra. The other one only has RW, read and write. But this one has read, write, and execute also. Okay. That means now it has produced an executable file. You can actually run this file by typing /shuffle. Okay. /shuffle. /shuffle. Yeah, hit enter. You should see the exact same behavior that you did. Yeah. Now you want to see how many lines it printed. So type again, up arrow, up arrow, up arrow. No, not this. Up arrow, up arrow. Oh, hit Control P. No,
Control
not
P?
that. Yeah. You see the 4 arrows on this thing. All right. So Control P will also do the same thing. All right. Okay. Now pipe that meaning vertical bar. Space vertical bar, put spaces on both sides. It's an operator in the operating system. Yeah, right, space. Now you said WC-L, okay? That tells you the number of lines it prints. Yeah, that's what we're gonna do. No, it's a WC space -L, word count, but give me the number of lines -L, right? Space -L. Right, now that'll tell you the number of lines you got. Hit enter, right? 1000. In your loop, are you printing 1000 times for size t I equals 0 to 1000? Yeah, so it says there's 1000 lines. Now, let's say we want to see, oh, there's lots of strings here. I want to see each string unique, okay? So here's one thing you can do, right? So up arrow again, go to the previous command Control P or up arrow. Yeah, right, get rid of WC-L and type less, okay? Less or more, one of these things. Hit enter. Okay, now you got the output of the program. That's line number 1 is 2. I thought line number 1 was 123. Was it 231? Oh, the first one itself is a permutation. I see. Okay, right. The first line is 231 and so on, and it goes all the way to the end and hit, I think, greater than sign. Hit the greater than sign. Yeah, see, that's the end. Okay, so it goes all the way from the beginning. So it shows you all your paginating. This is a paginating app, right? Paginating app. So it lets you see from the top to the bottom of this. Now, let's say we want to see all the unique numbers in here. Okay, so Q out of this, Q, hit Q. All right, now up arrow again. Up arrow again. Yeah, up. Yeah, all right. Instead of less, say sort. Okay, now this is an in-place sort algorithm, interestingly. Okay, these are all tools provided for free on Unix-like operating systems. All right, now pipe this to less.
So
pipe meaning vertical bar. You'll probably learn these things if you're doing a Unix Linux course. Okay, so in the very first few classes. Okay, less. Yeah, hit enter. Now you'll see that it's all sorted. Okay, alphanumerically. So all the 1, 2, 3s are up here. Okay, and space down, space bar, and go down. You'll see, the 2s come up next. Hit space bar, it'll go to the next page. Right, 2s, 3s, right? Everything has been sorted. Okay, now we took the output of your program and sorted it like that. Now let's say we want to compress all the lines that are the same into one with a count. Okay, meaning, you have 10 runs of 1, 2, 3. Just, scrunch them together to 1 and put the number 10 there. That means you got 10 repetitions of this line. Okay, and that's also very easy to do, right? So hit Q and get out of this. All right, now up arrow again. Right, get rid of less. Okay, and type unique, UNIQ, and then space -C. Okay, that says just give me the unique lines from here. If you have repetitions, just collapse them, and then -C says give me the count of all of the number of repetitions. Okay, and then pipe that to less. Right, pipe that to less. Okay, now you see how you build up these things, from same object-oriented programming and modular approach, right? You have different things that do well-defined things, and you just combine them, one output to another input, and so on and so forth, and you get, magical things happening, right? If you hit enter now, okay, there you go. It says you printed 174 123s, okay, 158 132s. And so it gives you a count of the number of repetitions of each of those things. It's really cool, isn't it? Yeah, so you did all that using, and this is your program. Now, let's say you want to go back to your program, and instead of printing 1,000, you're going to print 10,000 or 100,000, right? So Q out of this, and you want to edit this program. Let's actually say, I don't know what editor to use here. Let's say type VI, and then hit tab. Oh, you do have VI. Okay, right, space, and then shuffle.cpp. Yeah, hit enter. Okay, now I have to remember how to use this editor. Okay, now use I think type J. Oh, J moves down. Okay, all right. Get to the loop. Yeah, get to main in main where it says 1000. Yeah. Now go to the right, and I think you hit L for that. Hit L. Yeah, okay. Go to the 1000 but stop on the one. Stop on the one. Okay. Now I think you want to insert characters. You don't want to move. You want to insert. So I think for that you need to say I for insert. Okay, I. All right. Now it says you're in insert mode. Now say 100 times 1000. So 100 and then star. Yeah, and then star. Okay, so instead of 1,000, we're going to print 100,000 of those permutations. And also for the string, change that from 1, 2, 3 to 1, 2, 3, 4, 5, 6. Okay, so we'll have 6, right? 6, right? I see. You have to hit escape. You escape again to get out of insert mode. All right, and then up arrow. Up is K. Hit K. I want to see what happens. Oh, K. One and then left is it's so crazy, isn't it? We're in the day and age of GUI things, and I'm dictating letter codes to step through VI code. It is actually very fun, and it is really cool for me to hear myself even dictating this to you. But it is kind of nerdy and fun in a strange kind of way. Okay, so hit H to go move to the right. All right, now insert mode again. I haven't done this in 10 or 15 years, right? When I used to work in the industry a long time ago, some of the people I hired, junior Unix engineers, and I had to walk them through the code. And I wasn't a VI guy even then. I used to use some other editor, but I used to walk them through this thing like this. Maybe not VI, but something, right? So 1, 2, 3, 4, 5, 6, okay? Oh, I see. It's putting it there. Oh, I see. No, backspace, get rid of the 4. Right, you want escape again to get out of the insert mode. Now no, and then get to the right again by pressing L. Yeah, now you can insert. I think now it'll insert in the right place. 4, 5, 6. Okay, now you escape, and then a colon. Hit colon.
It's not doing anything.
Oh, it is a shift semicolon.
Oh, there you go.
Yeah, now you want to write before you quit. Okay, so you say WQ. Yes, hit enter. Okay, now if you cat shuffle.cpp, you'll see the contents with your change that you just made. Okay, cat shuffle.cpp, sh and tab. You should do it. Right here, hit enter. Now you'll see your change also. Does it say 100,000? Okay, now so now you want to recreate the binary because you changed the source code. You want to recreate the binary. Yes, you want to compile it again because you changed it. All of this happens, automatically in Xcode and VS Code. When you change the code, it'll detect its change and it'll compile it and things like that. But since we're doing it by hand, we have to do these things, right? But it all gets automatic after a while. It's fun to do. All right, okay. Now, so what you want to do is there's one more way to make this the compilation happen, and we can use a tool that's built into all Unix-like systems like Mac and other places, even Raspberry Pi, and it's called Make. Okay, so the Make is a program that will say, hey, this person wants to create a program called Jesse. How do I make? But there is no program called Jesse in the current directory. How can I make it? Oh, there's a file called jesse.cpp, but it's not Jesse. But I know how to make a Jesse from jesse.cpp. I have to call G++. Okay, and so I will call G++. Here's jesse.cpp, create Jesse. Okay, so there's a program called Make that will do all that for you. Isn't it incredible? Okay, so all of these functionalities are built in, available to you on your Mac, all of these machines that you buy, even on Windows. You get all these things built in. You just have to know where to find them. So we just say make space shuffle. Right now, if you hit enter, you will see make go and call GCC or G++. Okay, hit enter. Make will call G++. Oh, it's calling C++. Maybe it's another compiler. Okay, so it is calling the compiler, compiling your code and creating shuffle.cpp. Right now, if you run /shuffle, okay, /shuffle, don't hit enter, because it's going to print 100,000 lines, but we want to make sure that it prints 100,000 lines. So pipe the output, right? Vertical bar, and send it to WC-L. It is actually past time, right? WC space, it should print 100,000 because it should print 100,000 lines. Yes? Yeah, hit enter. So it's printed 100,000 lines. But if you send it to the terminal, it'll be scrolling on, and it'll be a pain to, right? Now, up arrow, get rid of the WC-L.
Oh, sorry about that.
Yeah. Up arrow, and then and then instead of WC-L, say sort, and then pipe that to unique, and then to pipe that to unique dash C. Okay, unique dash C. All right, now that will tell you each 1, 2, 3, 4, 5, 6. You will get I don't know how many 6. Oh, you'll get 120. 6 factorial is 120. Yes, because the number of characters, the number of permutations is that factorial. So 6 factorial, no, 5 factorial is 120. So 6 factorial should be 720. I see. All right. Now after that, unique dash C, pipe again, a vertical pipe, and say WC-L. I think you should get 720 because 720 permutations of 6 letters. Yes. Let's make sure that's right. So these are the mental sanity checks that you should be running all the time. You create code. You should get to some environment like this, run it, make sure you do the sanity checks. Oh, it should be 7 factorial, 6 factorial, right? And then you know that there are no, silly bugs. Okay, hit enter. I think you should get 720. Or 720. That's because 6 factorial is 720. And then it would have printed. If your algorithm was correct, it would have not missed any of the permutations. It would have got all of that. Yes, that's why you're getting 7. But what we'll do is do it while take it one more level. And so up arrow again, get rid of the WC-L. And instead of WC-L, say less. Okay. Now it'll show you all the 720, but inside of a pager. So hit enter. You should be able to see. Now, if you look at the numbers on the left, let's say how many times that particular pattern has been seen. Now you see here that all of the numbers are roughly close to each other, right? 100,000, this is what you get. But if you did like 1 million or 10 million or 100 million, the numbers will be even closer to each other because randomly everything is uniform. This is how you can say that pseudo rand, actually no, it returns the shuffling. Yeah, the shuffling is happening in a uniform way, meaning that everything is equally likely. Yeah, and your algorithm actually does the right thing because no pattern is more likely than another. So these are sanity checks you can run every time, especially if you're doing machine learning and AI and things like that, and you're playing with lots and lots of data. Every time you're playing with data, you're transforming it from one form to another, you go through some, I don't know, uncountable number of transforms before you feed it to the algorithm. But what I have seen really good engineers do is that every time they transform the data, they'll run sanity checks. Okay, they'll say, all right, has it done? Because even the slightest error here can just keep amplifying, and it'll create all kinds of headaches downstream. So every time it actually helps to be paranoid without pain. Okay, initially maybe noobs will be paranoid with pain, saying, oh, if it breaks, I'm going to be fired and things like that. No, but seniors and experienced people are still paranoid, but without pain, saying, well, I don't want it to be wrong because all these things are going to mess up otherwise. I'm just going to take my time and make sure that it is bulletproof every step. And they will make that they'll be absolutely certain at the end of each data transformation cycle. Because once it goes into the system, and then it's going to be training for 15 hours over a huge data bank, that's a lot of energy, lots of time. Yeah, and waiting for the results and then seeing that you had a silly error. All of that happens, by the way. Yes. So, but these are the techniques that you would use to mitigate that happening when you actually go out there and train massive systems. These are the habits you develop when you're transforming anything, working with anything delicate, right? That could go wrong. You always start getting paranoid. It's okay to feel paranoid and bad initially, because eventually you'll feel paranoid and not bad. But that's because you've been paranoid, checked things, and make sure it's working repeatedly, and then right? So that kind of thing will happen eventually, I think, for everybody. But you have to check the data, like we did with the Unix system here. Getting through to the pipeline every stage, making sure all of the it's uniform distribution. It's not like normal. In fact, I can if not maybe I thought I could show you another trick here where we'll use exactly the same thing, but we'll introduce something to do with the central limit theorem, meaning you sum distributions instead of rand, you say rand plus rand plus rand or something like that, right? Then you'll have more occurrences of some patterns than the others. But if you look at it like this, you'll actually see a bell curve. It's actually very nice to look at the these things. We did it in one of the very ancient classes here on Zoom, I think. You can actually see the bell curve, just by summing rands together. And that is a beautiful illustration of the central limit theorem. So if any of you doing statistics or learning statistics, you have to learn statistics if you're going to do machine learning and AI and all, yes? So you can actually show your prof, say, hey, here's a really cool demonstration in 2 lines, 3 lines of C++ of how the central limit theorem works, because you just take uniform distributions or any distribution for that matter, but uniform is free and is easy to get with rand. You just add them together and you get a normal distribution, a Gaussian. Okay, it's just by adding ordinary randoms together, and you can see the effect. You can see the virtual, all these really cool things. So anyway, I hope this was useful and interesting. We did actually do some cool stuff here. We implemented the sort, the shuffle algorithm, and then we did sanity checks on this. The last bit to do with Unixing and data checks and so on, they're not absolutely useful for CS2A. But as C++ programmers, I think they're tremendously useful to you, okay? Because, you're close to the machine. You need to know how these things work. So if you're C++, I would strongly recommend that you enroll in Linux courses, do a Linux, whatever it is, a boot camp or workshop or something like that. You have to learn about Linux and working on the terminal and the command line, because that is a hugely powerful companion you'll have in your programming, including all AI agents and other things that you'll have, obviously. But having power over the terminal is something else, and it greatly enhances your programmatic way of thinking through solutions, because then you'll automatically start thinking about things in a higher level modular way. So I'm going to write these things that I'm going to pipe the output of this into that and that and that and that. You just chunk things together, and everything just plays out in a very computational kind of way. Otherwise, you'll write one massive program that's going to take everything and digest everything and print everything out. And then people get confused and, bugs happen all over the place. So this way you break it down. Naturally, you're forced to do it if you work on the terminal. So those are things that you can start thinking about and playing with. Okay. So I'm not going to be meeting you on Thursday, no class on Thursday, but you will be doing your exam. So best of luck for your exam. I want to see Jesse. Thank you so much for typing. Okay. And who was that before you? Was it Agnes? Was that you? Oh, Asmita, you tried, but your share didn't work. Who was it? Enzo and Jesse. Okay. Next week, we'll go with someone who has a PC, because I don't think we need a Mac and a terminal and so on. So Asmita or someone, you have a PC, right, Asmita? Yeah. And someone else also said that they have a PC. I checked at that time. So you can do that, and we'll start playing with objects. Yeah. Oh, Byron, you have a PC too, yeah? Yeah. So we will do that. And certainly when we start talking about objects, Andre, your question will make a lot more sense when we cover pointers, for sure. But as and when we start covering objects and so on and so forth, you'll see, right? Well, this ampersand means something completely different here. We take the address, and here we're passing by reference. Because when we pass by reference on the other side, you don't treat it as a pointer. You actually treat it as an object. That will only become clear when you start looking at, well, even now, for example, if you pass an address, but that's not what's going on. Maybe it's just getting used to it, okay? But it'll happen for all of you guys by next week or a couple of weeks from now. So I'm very happy. I'm happy with the progress that you guys have made from the Reddit posts that I'm seeing. But there may always be some students who are not posting on Reddit and who are not sure how things work and so on. But at least you're all coming to the class, and all the people that I see in class are interested and doing stuff and having fun and coding, right? So I don't have any reason to doubt that you guys are behind in any way or lacking some, serious concept, or have some serious concept gaps. If that is the case, you should let me know. Okay. Hey, Fatima, I haven't even heard from you at all today. Okay. Because I spoke to you before and you didn't respond. Are you there? You're there, right? I can see your head now. Okay. For sure. Yeah, you're there. Okay. Right. So you should all ask me, or, in the forum, if you don't understand something. If you feel that the answers you're getting in the forum from the students are not helping you understand something, you should immediately ask for a one-on-one with me. We'll do a Zoom session. We'll record it and put it on YouTube for other people also, where you can basically say, hey, I don't know this particular thing. Can we live code something, right? We'll do a half-hour session with you anytime, right? Doesn't have to be during class time. So separately, maybe just you and me, or maybe a couple more students. and then you code something. I'll dictate the code, and you'll type it just like now, and we'll make sure you understand it. And that we can take a recording of that and put it on Zoom, right? So other students will also say, hey, I also didn't understand passing a vector by reference. Now, after I saw, Aiden and Anand coded on screen, now it's all very clear to me. Right, so you should all take that opportunity. Either your students, classmates help you, or you should ask me. Okay. Unfortunately, we don't have an embedded tutor this time, but you can certainly ask me. Okay, I post on the Reddit for sure. Okay, give your classmates a chance to chime in first, and then I'm always there. Okay, if you're totally stuck on something, you can ask for me to also, chime in. I'm happy to do that. But ideally, I would like to see more from you guys. Was this a useful class? Yeah, jazz you up for the midterm, because in the midterm you're going to have questions with the ampersand. Okay, passing by reference and passing by copy. Yeah, I think there's at least 5 points about this, so just brush up on those things, loops and all those other things. I plus plus, I minus minus, what is the value of this variable after the loop finishes? Okay, you can't afford to take that and copy it and run it and so on, so just get in the habit of running it in your head, like we did with the when with the shuffle. I wanted to make sure that it actually does all of the indices. I want to go to the end, this end, that end, right? And some random index, like mathematical induction, right? Okay, you want to make sure all of those are clear, then you don't have to check every single location. That's it. Okay, thank you all so much for your patience. Yes. Oh, Sophia, you have a question?
No, it's just this is my first midterm exam, so I don't know how to how this format will be.
It'll be just like the data rep quiz. You did the data rep quiz, yes?
Yes, so
It'll be
it
just
will
like that.
be okay, and then you put submit when you're done, and that's it, kind of.
Yeah.
Okay.
You have to hit the submit button. Okay, so last time I think someone had a problem saying, well, I did it, but my exam wasn't recorded or something like that. You have to make sure you're connected to the internet and hit the submit and make sure that it comes back to you and says it's been submitted.
Okay. And it should be within 2 hours.
Yeah, you get. I think you only get. I think you only get 1 hour for the midterm.
I mean, can we think that at the time, like have a break, go to the toilet, like
No,
it's like online?
you can take a short break, like 5 minutes shouldn't matter during the
Okay.
midterm, but you can stop the clock will keep running. Once you start it, you can't stop, pause it. But you can go for a
Okay.
bathroom break or something like that when the clock is still running.
Okay, but when the time is over, it's like
Yeah, when
you
the time
have
is over, it'll
to
automatically
click submit before.
Yeah, it'll automatically submit. If you don't submit after the time is over,
Okay. So it's not that you will lose everything, and it's like
no, it'll
maybe.
submit. It'll submit it. The only time you lose everything is if you have, your computer shuts down or internet outage or something.
Okay.
So don't do it on an iPad, on a phone, on a bus or train or anything.
Thank you.
No worries. Any other questions?
The
No?
like sorting
Yeah, sure. Go
algorithm.
ahead, Tristan.
I was gonna say, are the sorting algorithms relevant at all, or is that like for like the
Not for
final?
2A, yeah, you have a brief introduction to sorting in week 10 or 11, but that's only touching upon it, right? We'll do more sorting in 2B
Okay.
and then a lot more detail in 2C.
Okay.
So we need to revise
Look at double
everything
sort. No. Yeah, sorry.
till. So we need to revise everything till last week, like this shuffle and stuff we did today. It won't be asked or something.
No. This what we did, this shuffle, the specifics of what we did will never be tested in any class, in any exam. But you'll be tested on the ampersand, and we just the shuffle we did today was only to help set the stage for introducing the ampersand and stuff, so that you can have questions, ask about, hey, what does it do, and so on. That's the only reason we use shuffle. We could have done any program. You won't be tested in the midterms, any exam. You won't get a question on, hey, in the unfumble game, what line 27 of unfumble game, what happened? No, that's all just part of class and having fun in class. You're not going to have questions on what we do in class. Yeah, any other questions? No? All right, okay. So in that case, I want to wish you all the very best of luck for your midterm. And you should take it with a light heart, not too stressed about it, because if you totally screw up your midterm, meaning you get less than 50%, you just remember that and ask for one more chance for your midterm in week 11. Okay, week 11, the week before the final, I'll just reopen it for you if you totally screw up. Okay, if you got like, oh, I got, I got 89, I want 91, I want one more chance. No, you won't get it. Okay, if you do a totally bad job, then you'll get another chance in the midterm.
Oh, wait, Professor, for the midterm, are we not going to have FRQ, like where we just submit a code? We're not, right?
You're not going to have to write any code, but you'll be asked to look at code and run it in your head and say, what is the value of X after the above code runs is so and so, right? And you have 4 choices and you have to pick one.
Oh, so it's just multiple choices. Okay.
Not all multiple choice. You'll have true or false, multiple choice, and then multi-choice, meaning that more than one will be answered correct. Those kinds of any objective. I think that's a right type of question. Objective
And
means
will be also with data representation as well, like from the first week or the 0 till now, like what the concepts
yeah,
will
well,
have there.
data representation not so explicitly, but it'll be there because you may have for loops that won't complete because it has the wrong data type. Yeah, so you need to know about data representation. But you won't be asked like, oh, is this two's complement and that kind of thing. Anything else? Okay, all right. I'll stick around for a few minutes after all of you are gone, just to make sure that if someone wants an officer or something like that. Otherwise, best of luck, and I will see you guys next week. Okay, next Tuesday. It's like a whole 7 days from now. Okay, but obviously, if any of you want a class, I'm happy to convene one for a bunch of students who are interested, even this week, later on this week. Okay, best of luck. I'll see you guys later. Bye.
Professor, I have a question.
Yeah, sure. Go ahead, Andre.
Yeah. So, I'm just curious, right? So, earlier when you said that a pointer is an address, I can't wrap my mind around that because for me, like what I read up on it, it's the theory was that a pointer points to the address, hence why it's called a
Well, I
pointer.
guess it's just a semantic, or what people, describe it as. A pointer variable is basically just a memory address. So if you have a pointer P, a pointer P in your computer is going to be whatever the size of a memory address is. Maybe it's 16 bytes. 16 bytes, right? So your pointer B will basically be a 16-byte address right there.
Okay.
That variable P equals that number. P is equal to that 16-byte number.
Right. So, I mean, can I screen share real quick?
16 bits. Yeah, sure. Go ahead.
Yeah, so okay, so this is just what I like came up with, right? And then
Uh-huh.
like let's say we have this int, right? So this int is like stored in some area of the RAM.
So you don't know what the pointer to int is. You know that there is a variable called int whose value is 9, but I don't know where it is stored.
Right, and in order to get where it's stored,
of Rn, yeah.
And then to get where it's stored, we just dereference
Yes, you
that.
use the ampersand. It'll tell you this is where I'm stored.
Okay.
So now PRN is a variable whose value is that big, address. That
Right.
64-bit address.
Right. Okay. Forgot what I was saying earlier, but I was like, I was more curious about like the reason why the default behavior isn't in place. Like the default is to always make a reference. Like is that for safety reasons?
No, the default in C++ is to pass by copy.
Yeah. So why is that? Is that for safety?
In programming languages, yes. Well, actually, that is not strictly speaking true, because if you are programming in machine language, you see, even in machine language in assembler, you have the option to pass by copy and pass by reference. In fact, if in assembler code, if you want to call a function, you would push the value on stack, But if you want to pass a reference to the object, you'd have to push the address and indicate somehow, I guess. Yeah, so the
Okay.
default, I think, to pass by copy, you can't say it is for safety because in Java, everything is passed by reference. You know, in Java, you always pass the actual original object. Yes, in Java, an object is a pointer to an object. In Java, every object is just a point. That's why when in Java you return an object, you can return null because
Okay.
everything is a pointer. And
Right.
and to make matters worse, in Java, when you pass an object to a function, you cannot mark it as const, meaning that, well, I'm giving you the original, but you're not allowed to change it. Right? In Java, you pass the original, and you're just basically sitting there praying that the caller is not going to screw up your object.
Right. Okay.
Yeah.
Yeah.
Here, C++, you have three different ways. You can pass the original without a const, meaning the caller can screw it, and you either you don't care or you want them to change it, or you can say, I'm giving you the original, but you cannot change it. If you try to change it, the compiler won't let you. Or you can say, I'm just giving you a copy. You do whatever you want with it.
Right. Because earlier I was thinking like, oh, maybe the reason why like they do a reference is because they don't want the user to change the original object. But why is it so bad to change the original object? Like, is it because
No,
like you
then you
can
can't write.
possibly
Yeah. If you're the library, if you're creating a library for public use, okay,
Yeah.
for your own use, it's different because you know the ins and outs. But if you want to create a library for public use and you want to release some program out there saying, here are some functions, you can all use it, right? In that case, it makes sense not to have right. No, hang on, I lost track of what I was trying to say. What was your question? Is why not? Oh yeah.
Yeah,
You're
why
saying
not change the
everything called by
original
reference
yeah.
instead of copy. Yes.
Yeah.
Yeah. So you can say, well, I have these parameters. But I'm going to let anyone change these parameters. Anyone change my internal variables? Then your own library, inside of which you may have objects where you keep stack, you keep state, right? So you may have a library, an object. You let people create an object, and the object has certain properties inside of that, right?
Right.
But you want to keep these private, and you don't want anyone to change these. So if someone says, hey, what is your length? What is the length of this, table that I created in virtual space? And say, here's the length. And you give them the actual variable. But in this case, you can give them a scalar. But let's say it's an object. You have to give them the actual thing. That person could change that, and it'll change your internal representation of the table.
Okay.
So that way, you cannot create a reusable program, reusable library that is suitable for everybody to use. Basically, what you do is you create a module or a program, and you make it usable by everybody by restricting the ways in which it can be used. If you make, if you say you can use it any way you want, then it's not very useful because, people will break it, and most people will say it's too unsafe for me to use because I do some things and then, I get mysterious errors.
Right. Right. That
So
makes
you can
sense.
say, you can just create a very walled garden and say, this is the only way you can use this. There's no way people can break it.
Okay.
So that is I think the guiding principle behind saying everything goes by copy in this language, right? By default, you can't, screw around because you're going to be writing system programs in C++ and C.
Yeah.
This is not variables going to be flying around all over the place. You can have these, sensitive guys, saying, oh, yeah, right. So,
Yeah.
copy, and then at some point, well, we do know that for arrays, which were big objects, you can do by copy because it'll be very wasteful, especially when you.
Yeah, but isn't that like but here's the thing, right? Like in Python, right? Like you're always doing like copies.
No,
I mean, I
think
guess
it's always copy, but I think the system in Python optimizes things so that internally in the execution, the runtime environment, if it detects that the object is not going to change, it will just do a reference anyway.
Oh, really? Okay.
Because if you think about it, that transformation by looking at the just immediate context and saying that the inside and outside, it's there's no change happening here, that doesn't require a lot of AI or any new intelligence. That could have been built into compilers like even 10 years ago. Saying, well, this is a simple optimization that the Python interpreter will do. It'll just, So even in Java, other languages, when you pass things around, you may think it's by, copy, but internally it'll get optimized. These things will, except, certain cases like, big vectors and so on and so forth that you pass around and the system is not able to catch. Then, you have suffer the overhead. You won't know what's going on. That's when it's, when you're doing machine learning, you'll be passing these huge matrices, right? Hundreds of thousands of rows and columns.
Mhm.
They're very big. They may take gigabytes of RAM, and you can't afford to pass these by copy, right? So
Right.
a vector of vectors, and you're going to pass a reference to it. That's all.
Okay. Um, thank you. Enzo, do you have questions or not? Because I don't want to hog the professor.
It's okay. I don't have any constraints on my time, really.
Okay.
To be honest, I was like, I had a brief one, but I was actually sort of interested in what you shared your screen. So like I made my own version of that to test out things. So what is like the I don't know, what's it called? Like
The star?
the star do?
The star is like it's telling it that this is a pointer. I mean, at least that's what I think of it is. Like
Yes,
that's
the
how you
star is
initialize.
contents of a memory address. PTRN is a memory address. It's like say 64 bits. PTRN is a variable of 64 bits. It's an address. Star of an address is give me the contents of whatever is in there in that memory address.
And if you like, okay, if you were to make the initial variable without the star, the default
You're gonna get
would
9, I'm
be
pretty sure.
would be
You just get
9.
9. Yeah. Because
Oh,
I
yeah,
mean, I don't think PTRN is a special like thing. It's
but
just
you can't do just without the star, but ampersand on the side won't work.
Oh, really?
Yeah, it'll say you're trying to assign an address to an integer.
Okay.
Does it say that?
Oh, so the ampersand is saying the address. It isn't saying the variable. And then PT. Okay, so you sort of need them to match up.
Yeah.
Well, no, it is saying the variable.
Well,
Because the
saying the
variable
address that
is
holds the variable.
no. The variable. Well, I think that well, the way you initialize a variable in C++, you go data type, variable name, right? So PTRN is a variable, but it's a variable that is a pointer which stores the address. That's how
The
I
way
think.
that it is obvious is that the contents of the variable is an integer. So, if a variable has contents, then obviously it's an address.
Yeah, so this is a variable.
Yeah, PTR is a variable. The contents of that variable
is an address,
is
which
an
is an integer.
Is an integer. Right? So that's why you have int contents of PTRN.
Okay, and sort of it's so you also need the what was it? You said astrophy, is that what's called? The star?
Asterisk.
Asterisk.
Asterisk, yeah.
Yeah, so you need the asterisk if you're going to use the ampersand, because the ampersand's like an address and you can't give like an integer an address. Could you give a string an address? Like
What do
and
you
not
mean?
use
What do you mean?
like
Oh, we
if
can try
instead
that.
you did string, yeah.
Yes. But var
Nah.
no, it'll say var n is not a
Oh.
string.
No, but that I don't.
Yeah, you can make
Okay.
that an address. Yeah, string no, var n equal no, it can't be 9 anymore. It should be 9 within quotes.
Oh yeah.
No, single double quotes.
Yeah.
Semicolon.
Okay.
Wait, why is it thing so thin? Like my cursor disappeared. Okay, anyways. Oh wow. Okay.
Wait,
guess
if
you
it's a string now, could you delete the apostrophe or
The apostrophe?
the asterisk?
No. Because you got it. Because the asterisk is a
Oh
special
no.
like
Enzo's saying
thing.
what happens? What happens if you don't have the asterisk and run it?
It's not gonna. I don't think it's
Yeah,
gonna
because
work.
like now that it's a string, does it make a
Well, it doesn't
difference?
matter of the data type because when you're trying to do a pointer, you need the asterisk to tell that it's a pointer.
A pointer.
Yeah,
Okay.
it's not.
No,
I don't
but
think it's a
Okay.
pointer.
yeah, to Enzo's point, what he's saying is that, in this case, if you don't have the asterisk, it'll say, hey, your left side is a string, but the right side is an address. They don't match. You can't assign a non-string to a string.
Yeah, because
Yeah.
when I originally had them mismatching, the arrow would be like it's like, yeah, it doesn't match, and then it says like the right side's an address and the left side just an int. And I was like, well, if the address is a bunch of numbers and like letters,
Yes.
couldn't
But
that be
it's
a
the same
string?
as assigning an int to a double. Okay, it'll come plain.
Yeah, it's not the same. Yeah, I
They're
realize
both
that
numbers,
now.
but yeah,
It's
different
different.
kinds of numbers.
Yeah, and it's like you need the asterisk and the ampersand sign to match up so that you can sort of toggle between the address and
Don't worry about it, okay?
the
Because you know it's not like that. We don't have to be mindful about matching things up, and we're not going to be using it like that. It'll just come naturally when we get to that place, okay? So
I
don't
see.
worry about pointers and addresses now. Just what the only thing you
Okay.
need to know is that the ampersand right now is not. Don't think of it as address related at all. Right now,
Editing the original.
it is just reference. It just means the
Okay.
parameter is being passed by reference.
Okay. And then my actual question I was gonna say a little after for was at the very beginning of the class you had talked about how like serious computer science programmers will sort of keep going with computer science even after like AI because they're sort of doing it because they like it or something like that.
Yeah.
But wouldn't you say that essentially computer science people who do it for like efficiency, like trying to make the most efficient program, would fall out, and only people who do it for the creative aspects of computer science would continue?
Well, you know, why would people try to make it more efficient when AI can actually make it more efficient, as efficient as you want it to be?
Yeah, well, it's like you made the comparison between like making art and how like someone's a better artist.
Yes. So trying to
but,
make
like,
it more efficient itself is an art form.
But I feel like AI can sort of
Yeah,
do
it can
that
do
art
it
form the
easily.
best. So
Yeah,
like it's not like art is like only one kind of the computer science thing. Computer science has both the artistic side and the efficiency side.
No,
And if
what
AI
I'm
can
saying
do
is
the efficiency
no.
side.
I'm saying the pursuit of efficiency itself is an artistic endeavor, because you know, think about, you know, making a sculpture or a sculpture. You may get to the fine details and spend a lot of time there, and you say that's not art. They're just trying to make the, you know, angle of this thing correct or something like that. But for that person, they're not working on the angle. They're just looking at the whole thing and make sure it's perfect and beautiful and everything, right? So the efficient part of a program is part of its aesthetic appeal. So when someone is working on getting the program to be as good as possible, it is exactly the same feeling as an artist trying to make a sculpture or a painting as beautiful as possible.
But if AI can just like min-max that efficiency
Yeah, Michelangelo
part,
or some great painter did these really cool things, right? Think of them as a, you know, some kind of AI. It doesn't mean that other people are not going to do it.
But
Wait,
like if
Enzo,
you're
are you talking about people like who do it for the love of the game, basically?
well, it's like I get that, but I feel like computer science is going to change a lot with AI, and the fact that people who are just trying to make the most efficient software or something, like that's not really going to be a job anymore. Like, yeah, the creative aspects will still continue, but just like the most efficient, like solely based on the most efficient.
No, I know it doesn't have to be just explicit art. Just the fact that you have these incredible algorithms themselves, right? That have a beauty of their own. Like our mathematics, some theorems are beautiful, right? So there are mathematicians who just spend their whole lives refining a particular theorem to make it more and more beautiful that only other mathematicians can see the beauty of. But they know, you know, but we look at them and say, all right, they're just polishing this piece of marble to make it the shiniest marble ever. But we can see the shine, but those people can see the shine. So they're just working on it forever as though that's a purpose in life. But what they're doing is just making it, you know, getting rid of all of the, you know, unevenness and everything and making it more and more beautiful. That is how a programmer also feels about programs. So having it working is fine. AI can obviously do it, but you know, what if we didn't have AI? And because the process of making it fine and cool and as good as what AI can do, that itself is a fulfilling process. For production, I don't need to use my program. I'll use the AI program. But for entertainment and for self gratification, I'm going to try and do it myself to see if I can do, you know, get the AI thing just through intuition.
Okay, so basically from what I can understand, it's like the business, like the economic aspect of it, that might change because you can just sort of use the AI for it. But sort of everything to do with personalness, like it's just that's what stays the same.
That'll stay the same, I think, and not just computer science. All of these other fields where people are, getting paid to do ridiculous things. They won't have to do these things when automation is, full-fledged as AI might make it. But technically, you don't need any of this, to be perfectly happy. But in a culture where automation is supposed to give you the luxury to withdraw from mundane tasks, this is the best they could get to, right? So you can get all of these boring things done by the machine, so that people can just focus on the exciting, interesting part. Really, if you think about it, the only times that even programmers or anyone feels really satisfied is when they do something really creative, right? When a new program or anything that is creative and creates a wow moment for other people and say, hey, that is really something enjoyable, that is when they get a kick out of it and get juice out of any activity, and that is just going to become more common now.
Really? I feel like they get a kick out of it when their startup is valued at $1 billion.
No, I don't think so.
You don't think so?
Yeah,
I feel like the majority of
I used to think
people.
that because before you get your company valued and things like that, but after you make a certain amount of money, these valuations really don't matter that much.
Really?
Right?
But Professor,
Hmm?
don't you think that most people that are in CS are more like logical and pragmatic? I feel like a lot
Yes.
of people in CS see CS as a means to an end, not
No,
as
I don't think so.
something.
No, I think that'll change, right?
You
I
think
don't think
that'll
CS is a
change?
means to an end anymore.
Oh, really?
I don't think so. I think CS will become like the art department, where people go to learn something that is going to enrich them.
Yeah, but they're gonna work at Starbucks though.
No, I don't think so. No, they'll use CS to create beautiful things and sell, or they'll use CS to entertain themselves, where they're getting free income, or social security will probably increase, so nobody will actually have mundane things. Yeah.
That's
This has happened many times in history before, just not in this short history that people are taught. In many civilizations, many countries, many places where we've had people living for a very long time. After a while, where people realize the self-sustaining way is the best way to just find happiness, because there's no external dependencies. You can just sit down and just focus on what you need to do. Then the government basically provides for the basic minimum, which is all you need for a happy and contented life. So you can spend all your life, all the time you have, other than basic needs being taken care of by the government, you can take that and put it to use to improve yourself and others around you.
Interesting.
All right, okay. Well, you guys are really young, right? By the time you're, in your 30s or 40s, things will change. But a lot of these challenges will be the same, and maybe you'll have answers from now that you can import to a later time. But everything will be changed, because when I was your age, things were very, very different from now. Yeah. And now there's so much technology everywhere. This is not something that I even could imagine when I was your age, right? So because when I was your age, we didn't even have TVs. But back in India, we had one TV, black and white, and we used to switch it on for a program, once a week on Saturday or Sunday or something like that.
I gotta go. See you guys.
That's the
Peace,
extent
bro.
of, yeah.
Hey, Professor, this isn't related. Well, it's kind of related to CS, but I just wanted to see your advice on something, if that's okay.
Yeah, sure, no worries, go for it.
Yeah, so 'cause right now I'm a computer engineering major, which is basically like electrical and CS. But I was thinking about switching my major to mathematics.
Yeah, math is a
Mathematics.
fantastic major. If
Yeah.
you don't want to do computer science for a living, which I think is because you can still do AI and be a good AI engineer. AI is more engineering than science, because it is prompt engineering, how to get something that you don't understand, because nobody understands how AI works even today, right? Even the
Yeah,
people who
yeah,
built
yeah,
it,
yeah,
because AI we know how the prediction happens up to a certain limit, but after that, it's
Yeah.
just trying to explain what happens inside by looking at nodes and right. Nobody knows this mysterious thing that just happened, right?
Yeah, yeah.
And so it's more engineering, saying, well, we have this thing called gold. How do we make something out of gold? By coming up with creative prompts and all these things, and how to make it more efficient without understanding, right?
Yeah. Like I saw a video where they were
Yeah,
explaining like we actually don't know how like AI is actually like thinking, so to say. It's
Yes.
kind of a yeah. But yeah, back to like what I was saying, like I was thinking math, because I was like on one hand I was afraid, okay, if I'm not able to like do a master's, is that gonna limit like my employability? Like even if I have like
You do
good
math, okay? I think
resume.
you do math wholeheartedly, meaning, this is my advice, whether you're able to take it or not, enroll in math, okay? And then forget about, for the next 4 years, forget about Prime, Netflix, or entertainment, Fortnite, video games, nothing, right? So you say, I'll do this after 4 years. It's not that you're giving it up ever, right? For 4 years, just focus on math and try to get to the bottom of everything you learn, right? And even more, whenever you have time, just do that, right? But put your social life on hold for a little while, or minimize your, social things, or whatever it takes. But give it your all, okay? Give it your all. You'll be perfectly set even for advanced computer science later, okay?
Yeah,
Easy
yeah.
fall into place because it encourages, even hardcore computer science, encourages a certain way of thinking about things, okay? Clarity of thought and critical thinking. That is going to be super important in everything you do.
Yeah, yeah.
And I think pursuing a math major wholeheartedly, not even today, we have lots of math people who are doing it for a job, or, or a PhD or a doctoral fellowship or something like that. No, don't be like that. You do it out of your own interest, like Terence Tao or something like that.
Yeah, so what if I were to explain to you why I wanted to switch? Like my aspiration, it could be misguided, right? So the reason I was thinking about math was because I already completed all the lower division math, like everything, differential equation, everything, but I still feel like I'm not very I still feel like I'm not very strong at math, and like my logical reasoning isn't fast. So the reason why I want to pursue math is because I feel like everything is a muscle, right? That's my mindset. Like everything can be trained. So I feel like if I'm able to train myself to just like really understand all the theoretical math,
Yes,
everything
yes,
in the math major, it would just make me smarter, and that's my end goal at the end of
yes.
the day, not to like only have specific skills, but just to increase my intelligence attribute in
Okay.
general.
Yeah. All right. So I see where you're coming from. Oh, hang on. I see on page. I wonder where it's passing. Yeah. So yeah. So here's what I would suggest. So if that's what you're after, why don't you stay in computer science? But in
Really.
the time you're saving from, all the social and other things that you're shaving off right now, right?
Hmm.
Put it into all the other courses in math that you've already done. So meaning you don't have to enroll in new math courses, but differential equations and all these things. I'm pretty sure there are lots of things in the class that you might have skipped over because it wasn't important for the exam, or, or not emphasized enough, or so, or the prof didn't have enough time to cover, right? Just get the textbook, make sure you read it from cover to cover, all the, nitty gritty, all these little starred, bullets they have, because all of these things in math books are really cool. Sometimes they have bullets and, footnotes and so on. Forget about the
Yeah.
historical footnotes saying a Jacobi invented this and all that shit. Not necessary, right? But they
Yeah.
may have some interesting footnotes saying, interestingly, this ties into, Cauchy's theorem on 45, right?
Hmm.
And they say some interesting footnotes, like those are important. But we tend to skip over those things in class, and profs don't emphasize this because it's not important for the exam. But
Right.
get the book, make sure that and since you're doing this thing that you already passed, you'll find it easy, straightforward, and you also know where to go for help, okay? But
Mm.
take it and say, well, you know what, I did this for 3 quarters and got an A or something like that. No, I'm going to do it for 3 quarters, not for a grade, but no, not 3 quarters, 3 months, 1 quarter, one whole quarter. I'm just going to do this as though I'm doing the class, but I'm doing for my own.
Mm.
So just do it once, but that will also put your mind at ease. If you want to make a full-fledged commitment to math and say, I'm going to change majors, at least you know what it takes, because you've actually taken, because that's what you got to do. If you do a math major, you got to do what I just described to everything you're going to do in the future. So why not do it with something that you've already done?
Right.
So take differential equations and get to the bottom.
Like I did do that, but then I think I struggled to like extract specific, because the thing I didn't understand was like, oh, okay, here's what happens, right? I know the formula, like Bernoulli differential equation, but I would like take it for granted, and then when I read the proof, I kind of like I don't know, it didn't really click with me. So after like
Okay.
that first time, I just kind of was like, okay, like my mindset back then was like I'm trying to be an engineer, right? So I'll just accept everything, take it for granted. But
No,
now
no,
you're telling me that, oh,
that's why it doesn't work like for
should go
everyone.
back and really like understand instead of taking everything for granted.
I see. Because
Yeah.
you're in computer engineering. Yeah.
Yeah, yeah.
But that's how it is for everybody. When they read a proof, it's not all the proofs make immediate sense. Some
Hmm.
proofs don't make sense. The only thing to do is what I said during class. Don't ask someone or look up additional resources or ask ChatGPT to explain.
Yeah.
Right? Just say, all right, now I'm going to go play guitar or something like that, or play something and come back and take a
Hmm.
look at it. So
Right.
keep at it again and again, like 10, 20 times maybe, and then it just comes automatically. But
Right, right.
your own. That's why I said don't enroll in a class, because that'll stress you out and say, oh, I got to do this, right? Do something that you've already done because you know you can complete it, but now you're just doing it the second pass, right? You do this many passes, you cover all the nooks and crannies.
Hmm.
So
Yeah.
just do that. Do it with something that you're already comfortable with, that you know both ends of, like a course. Yeah, some calculus courses, I think pretty good. Discrete math is also very good.
Right, right. Yeah, I mean, discrete math was actually my favorite math. Just
Yeah,
because like it was
yeah,
more,
do discrete math, okay? Do number
yeah,
theory, because there's so many beautiful things inside of number
yeah,
theory that can
yeah,
just keep
yeah.
you occupied. Even
Okay,
when
okay,
you're
yeah.
biking, you'll have these interesting problems that will get hooked in your mind.
Yeah, and finally, just to reiterate, like as an employer perspective, right? You said like you've hired people. You wouldn't dis you wouldn't like put a math major lower if they had like a decent like resume with all like technical stuff, right?
If they knew how to program already, all right, even
Yeah.
if they didn't know how to program at all, if they were a good math person, right? If they actually did everything in math and they have the right perspective, I actually
Mm,
don't care at all, right? If I would actually hire them and I would spend like 10 or 15 days, it'd only take 10 or 15 days. If you've done a good math degree, sitting down with someone who's experienced, if I was sitting next to you,
yeah.
because even class, if you think about it, you're just meeting for 2 hours a week or something like that. Yeah.
Yeah,
But
yeah.
if you were working for me, I would be sitting by you 2 hours in the morning, 2 hours in the afternoon, and things like that, because you're going to be working for me eventually. So I want
Mm,
to get you up to, speed and everything. So
right.
math, make sure that you know all the details. If you know math,
Right.
that's fine. I
Right.
actually hired a mathematician for a programmer job before.
Okay.
Yeah, I have actually hired. Well, just one maybe. Pure, yeah, be a pure mathematician, and
Yeah.
turned out to be one of the best programmers.
Yeah, yeah, because I've heard a lot of sentiment, especially in like high frequency trading firms, everything. They're all like, oh, like math, physics, because it's easier. They believe it's easier to teach code than to teach like math, which, I think that makes sense.
Yeah, don't worry about what other people, say, because all these things are crazy. Most people don't even know what they're saying. Just focus on what you're interested in. I think you got the right instincts, okay? Saying, well,
Okay.
should I do this or math? If
Yeah.
engineering is taking you away from the scientific focus, just drop the engineering and do computer science.
Right, but on the other hand, I feel like a lot of like the very theoretical parts of a CS degree, they're not very applicable to like everyday engineering, software engineering, right?
No, no, it depends. It depends on how deeply you want to go into the theory, right? Or what kinds of theoretical problems. If you go into algorithms, for example, which, or, computability or algorithms and, discrete math kinds of things. But, algorithms, the efficiency of algorithms and so on and so forth, they're like applicable to everything you do in computer science out there. If someone doesn't know the basics of how algorithms work and how to prove whether an algorithm is correct or not, because many times you have algorithms, you don't know if it's the right thing or whether it'll fail, or you want to have to be able to prove these things. Yes, that's a very
Yeah.
mathematical. Even in CS2C, when you're proving things about algorithms, you're using very mathematical terminology there.
Mm-hmm.
Yeah. So
Yeah.
yeah, it is very relevant. But if you get into a very niche area in computer science, yeah, obviously, there's going to be theoretical work there that is not going to be seen in practical life for ages.
Yeah, I mean,
Yeah, in every field you'll see that.
yeah, it's just like the way I see it. I don't see a world where like if I had like a software company, I don't see a world where I would like strongly prefer a CS candidate over a math candidate that just taught themselves. Because it's like the things
Oh, a
that you
math
learn.
candidate? You mean you'd prefer a math candidate who taught themselves computer science?
Yeah, if they're able to talk about their projects and resume, and like if I grill them about their
That's what I
projects,
would do too. That's what I would do
yeah,
too. Yeah.
yeah,
Well, also,
okay.
if the CS person did CS not for a job, but actually out of love, they would be able to do the same thing too, like the math
Yeah,
person.
but that's very few and thin.
No,
I mean, I'm
there's
not even one
no,
of them, right? I
you'd
can't
be
even.
surprised. There are lots of people who enroll in pure computer science who
Oh,
are,
really?
yeah, they have a nose for math. Okay, it's not like the
Mm.
people who do real computer science are actually mathematicians.
Yeah, yeah, yeah.
Yeah.
So,
So yeah, it is depends. But today I agree that people who say software engineering, they don't talk about computer science software engineering. They are talking about people who put things together, which is what like 90%
yeah,
software engineers out there seem to be, right?
yeah, yeah. I mean, yeah, but it's just like right now, I feel like math is like the perfect undergraduate major because it's like you open everything up after you master it, right? Like for
Yeah,
sports, like
but math takes to master it just takes to master anything takes dedicated effort, right? If you're willing to give yourself to it, you'll make it for sure. Um, and computer
okay,
science is just like math. If you go into the pure computer science without the engineering and not having to bother about these other things that you find so uh, um,
yeah,
appealing, I think you'll find
okay,
the same kind of satisfaction even in computer science, because once you get to algorithms and everything, it's all about proofs and things like that and making sure this works and that doesn't work. How can you get it better? How can you get
mm,
it better by, right? So
yeah,
there was a talk that Knut gave at Stanford 2 years ago.
mm,
Yeah, I went there and he spent so much energy trying to, I think this is right, okay? Maybe I forgot, saying that the complexity of this function is log root n, but he was trying to say it is log root 0.5, some minor change to the equation,
yeah,
which shouldn't even matter for most people, but it just has this appeal to him, I think, because he talked with so much energy about that. So
mm,
that's the kind of thing that you will see in programming. In
yeah,
fact, Knut,
okay,
in fact, is a mathematician, right? He's not a,
yeah, yeah. Well, yeah, I don't know. I was pretty set on changing, but after today, I was thinking, yeah, maybe I should probably go through the old courses, really understand the proofs.
and then do computer science in the meanwhile. Do 2A, 2B,
Yeah,
2, the blue, red, green, okay? But blue, green, red. Just do it.
yeah,
Because
yeah,
red
yeah,
will take you a lot of time, but don't give up.
yeah.
Don't anyone. Just do it. And as long as at least one person is using it, I won't shut down the questioning system. I'll just keep it
Yeah,
up.
yeah, yeah. I was looking at 2C. I actually really like the topics gone over in 2C's like
Yeah,
binary tree.
yeah.
That seems very good for interview prep. So I hope to be able to get to that
Binary
level
trees are in
soon.
2B, not 2C.
2C,
No,
2B.
I think they're in 2B itself.
Oh, okay,
Maybe.
okay.
I don't know. I've forgotten now. Actually, I should
Mm,
look at them. Oh, yeah, yeah. Okay. Yeah, in 2B, we have general trees based on 2 nodes. Okay.
yeah,
And see, we have search trees. They're all interesting. All of them are, even the graph algorithms. Lots of really cool stuff.
yeah,
Do it. Okay. I'm not teaching 2C.
yeah, yeah,
Just
yeah,
send me email. I don't know if you have my email. Just send me email even if I'm not working. Saying,
yeah,
hey, I'm trying to do quest. Don't turn off the questing system.
yeah. Yeah, that's great. Are you paying for like compute to like run the server?
Not a great deal.
Not a great deal.
you know, yeah,
Very
actually,
generous.
I was paying slightly more last year.
Uh-huh.
This summer, I decided, okay, before I retire, I need to clean things up. So I just cleaned up a lot of things, and now I'm not even paying that much. Okay. Um,
Wow.
yeah, the first year I offered questing, I put it behind a load balancer with multiple questing systems and
Uh,
synchronization and stuff like that. I never had
yeah.
even an opportunity to use this because even a single server can take on so much load. Even when
Yeah.
people were hitting it, like it was getting 1,000 hits per, I think 5 minutes or something like that, one time.
Mm.
Even then, a single server was basically just able to comfortably handle that. So yeah, the resources are very cheap these days.
Wait, are you running off of AWS for the questing website?
Yeah, I'm running it
You
on.
are.
Yeah. But this summer I made it so that it doesn't have to be on AWS. So I just made it a tarball that anyone who completes Reddit quests and has a good profile on the Reddit as
Uh-huh.
a good helpful person who's been doing this for several quarters, they should be
Yeah.
able to take it and run it themselves on any machine, right? Now it doesn't have to be on AWS. So it's not an AWS image anymore. So I just have a tarball that people can use.
Okay. Yeah. Yeah, I wanted to ask you like another thing. I know it's been dragging on a little bit, but like when were you able to retire? Like,
Yeah.
um,
At Foothill, I think you can retire when you hit 59.5.
no, no,
I
no, no,
think
no.
so.
I meant like I know you're working right now, but I'm pretty sure you're not financially you're just doing it for fun, right? But I'm saying like
Yeah.
when were you able to financially retire? Because I hope
Oh, yeah, I
yeah,
could have retired, I don't know, maybe,
ages ago, right?
yeah, maybe 15 years ago, 15 years ago. Actually,
Yeah.
when I joined Foothill already at that time, that was 15 years ago. It was 10 years ago. 10
Mm-hmm.
years ago when I joined Foothill, I was able to retire at that time already.
Mm.
Um,
And did you just do this by like hopping? Because I heard hopping is how you increase TC
well,
the
what is
most.
hopping?
Like so like you every 2 or 3 years you'll try to get a new offer and then you'll
No, that's not what I did.
that's
I
not what you
just,
did.
I was at SRI for a long time, and then I
Oh
did
you're
a
oh were you at the is it the Stanford Research Institute?
yeah. So for a long
Oh,
time, I was a research engineer, but then after that, I decided to do my own startup. So I
uh-huh.
went through a couple of companies just trying to
Right.
see what they were doing as a startup.
Oh.
Yeah, and then I did my own.
Wait, so you were more of like a research engineer than like a
Yeah, I was
like
a
a
research engineer at the beginning.
oh, so more like on the R&D side, not like the
No,
development
research
of
engineer actually does things. They build things. The
okay.
very first version of Siri, I and Adam and a few other people in the lab put it together.
Oh, you still remember their names.
Yeah. But we built the whole thing. But
Uh-huh.
after Apple, they do it in a different way, right? They
Uh-huh.
put the final finishing touches, which looks different.
Uh-huh.
But I remember the very first time I gave a demo of Siri, we had 10,000 songs in
Mm,
my playlist,
mm.
and I asked anyone in the audience, "Hey, name any song, and it'll pick it up immediately." That was
Uh,
when people were trying to use voice to identify and buy ringtones. So you can imagine how long
uh,
it was, right? You guys don't
yeah.
even remember these things, but
Yeah.
you had to buy ringtones, and people would have to click through these painful interfaces. And then we said, we just use an agent that can recognize what you and give it to you, and we could do
Mm-hmm.
10,000 songs, the top 10,000 instead of just the top 10, which all the leading
Mm,
companies were.
mm. Did you enjoy like the process of starting making a startup too? Because like I also
It's
really
not worth it really, unless you're really,
huh?
really interested in doing something. If you want to do your own startup,
Yeah.
you want to do your own startup, you got to do it at a time when you don't have any other commitments. Okay, any other commitments, whether it's your girlfriend or family or whatever it is, you need to be able to give up your soul for 2 months or 3 months. Okay, you need to, not basically. I'm saying, for the next year or so or a couple of years until this takes off, I'm just going to give it my all. Okay, so you basically just that should be the mindset for a successful entrepreneur, right? If that's the
Yeah.
person, I would fund them even today. Well, I'm not investing these days, but that's the kind
Yeah.
of person that I would want to fund, because in
Really?
those days, because
N-
that is what really shows the investor that that person is actually jazzed up about it. Nobody wants to put money on someone who says, "Oh, I'm going to do this and it'll make money," right? I want to put money on
Yeah.
someone who says, "Oh, I want to do this because even if you don't pay me, I'm going to do it."
Hmm. Okay.
Yeah, but otherwise, if you don't feel that way about an idea, don't do it.
I do feel that way about an idea, but I also like I
But you
feel
have to
like
be, you have to be, you have to be completely committed, okay? And that takes time, and it is a test of your knowledge and your ability to survive. And
right.
you got to be sure and confident, because everything will break, obviously. And when you hit the rock bottom, lots of people will either commit suicide or give it up altogether and things like that. But you got to
Mm-hmm.
believe so much in yourself that you say, no, it's not the rock bottom. It feels like the rock bottom, but it's not going to be in a few, I'm going to stick it out and do it. You need to have the perseverance and a vision of where you're driving. You can't have, hit rock bottom and not know where you're going. You won't end up anywhere. So you need to have very clear vision of what this is going to do and what it's going to provide to the other people so that this will be successful. Otherwise, you could do some really cool stuff, but nobody else finds it cool. So you need to have all that really solid that's the driving force. I was talking with Enzo before. That is what is going to pull you out when you're stuck. Otherwise, if you don't have that vision, when you hit rock bottom, people will basically just give up or die. Right? And the rock bottom means it's not just the company that's not coming together. Right? When you hit that rock bottom, because everything looks like a failure, even to you, imagine how much it should look for all the people around you, your close friends, your relatives, your girlfriend, and all these other people. Say, this is not going to work, and this guy's a loser. So you got to be prepared. You got to be prepared to lose everything, including your world, all the people around you. You should say, well, this is what I'm doing, right? And then you actually find that the people who actually really care about you don't leave you, because they are after what you're after, not what what after other people are saying about you.
Okay.
So that is why getting to the rock bottom actually helps, because when people hit rock bottom, what happens is that all the fake people will just disappear.
Don't you feel like everyone is, personally, I feel like everyone, like even your own like family will like, I don't know, maybe it's just like my personal anecdotal,
No, I think,
but
if you have not just family, you have people who actually genuinely care about you, and they may be your family members, okay? And they'll always stick around. People who genuinely care about you will always be there and support you, because they just want you to be happy. They don't want to be happy in a particular way. They're saying, hey, Andrew, be happy, but only the way I choose.
you think there's people like that out
Yeah,
there?
absolutely. Yeah. But I have people. I just want them to be happy, even though, I love them in every single possible way. I just want them to be happy. And I don't want them to do anything stupid and wrong, which will land in, because, you're laughing, but a person your age actually has a lot of risks. Without your knowledge, even though everything is going rosy well for you, there are things that could happen that make you do things that you wouldn't normally do under same circumstances. For example, maybe you get accidentally hooked on alcohol.
Oh, maybe.
Many people don't get hooked, right? They may do it for social, but sometimes because of biological situations, people get hooked on alcohol or certain drugs.
Yeah.
And these things could impair judgment and make you do horrible things, which you normally wouldn't do when you are sane. But you may think that, oh, I'm just doing it, but that's not what you're not naturally doing. You're doing something quite dangerous, but you don't realize it because it's been masking you. And so I know a lot of people, not a lot of people, some people who have gone into really, really bad times, horrible times in their lives and deaths, because they made the wrong choices, which they wouldn't have if they hadn't gone the wrong path. So, and they were perfectly good people, sane people, intelligent people, but things happen beyond our control all the time, right? So even if you're the best possible person, you got to be careful and say, well, I don't want to go on the wrong path, because even the right path, there are so many beautiful things to look at. You don't need to go there to get the most out of life. The most out of life is just doing the right thing, you can get it, or not going on the wrong path. So that's all I can say, to people I love greatly also. They just need to be happy. I don't care if they are happy in a particular way, right? Or say to my kids, for example, from a previous life, I say, you don't have to do computer science or do exactly what I did to be successful. You do whatever you want, but you got to make sure that you will be, in a place where you're not going to end everything, or don't go to a place where you could get stuck, because life is a complex graph, right? And there's one path that leads from here to there. As long as you don't lose sight of it, you'll be going in that direction. But there are lots of these sideways things that into the jungle, that if you get lost in one of those, you could just get tracked, like Vegas lights, and just follow the light and end up in a really bad place.
Yeah.
And that happens. I've seen this happen to brilliant people in my own family when I was growing up too. Brilliant people that I thought were the epitome of good sense and everything. they've, and I can, even to this day, when I look back and say, how could that person possibly have done that? It doesn't look like them at all. But things happen. We got to be open to that. And I think many of the people that I have seen that have bad things happen to them, they just weren't aware that this could happen to them at all. They thought that, nothing bad is going to happen to me. And so you just have to be aware all the time and stay on your guard. Not in a taxing way, but just, it'll just become second nature to you. Just say, focus only on the good things in life and say, these are the only things I'm going to care about, because that takes up 100% of my time. Then you don't have any time for the dangerous things.
Wow, you seem very like, you seem like a very good you'd be like a very good
Father.
husband and father, and you're very like introspective. I feel like a lot of people like that I talk to nowadays, like it's very rare to have someone like think about all these things, and not just like
Yeah,
like a
actually,
lot
you
of
know what?
people,
The
yeah.
strange thing is all parents think about this, okay? Maybe not all parents tell that to their children, but once you become a parent, you will actually know, because you'll be thinking these things yourself too.
Yeah,
But
I feel like
becoming
I
a
think
parent
these
is,
things like right now, but
yeah,
yeah. Okay.
yeah.
Yeah, well, thank you for entertaining
No
me,
worries, no
Professor.
worries.
Yeah, it's
Okay.
very good talking to you.
Yeah, good talking to you too. Thanks for bringing
Yeah.
all these questions to the,
Yeah.
class. You
Yeah.
had interesting
Yeah.
questions about the ampersand.
Yeah.
Yeah, do these discussions on the Reddit, okay? These things
Yeah,
about
yeah, for
ampersand and
sure.
yeah, because lots of students were still Fatima, no, not Fatima, Sophia was still confused. So yeah, it will help.
Yeah. Yeah. Okay. Good night,
All right,
Professor.
I'll see you next week, okay?
Yeah, bye.